Hello, this is Aaron Daffern, creator of the 5-Minute Math videos. This is my walkthrough of the 2023 Algebra 1 STAAR. I'm using a modified version of the item analysis report from the state for this video. You can find it using the QR code on the screen or check the link in the description. And if you want to jump ahead to a specific problem, use the bookmarks embedded in the video, or you can just use these timestamps as well. Let's go ahead and get started. So for problem number 1, we are looking at writing linear equations. This is TEKS 8.2c, reporting category 3. So we have a table here, and it's supposed to represent some points on a graph of a linear function. So the fact that we've got this linear function labeled for us here is going to be very helpful. And so what we could do is we can just go ahead and highlight that, saying we need to look at the linear function section of our reference material. So if we look at the linear section function, the linear equations are right there. If we look at all 4 of our answer choices here, we notice that they're all going to be in that slope-intercept form. That one right there. So I need to make my answer look like y equals mx plus b, because that's the form that all 4 of these take. Typically, you're going to see slope-intercept form more than standard form, even though standard form is an option. And so I'm looking for my m, and I'm looking for my b. So let me look at my m first. Slope of a line, m, change in y over change in x. This is also on our reference materials. So let's just label that y2, and we'll make that x2. We'll make this y1 and x1. This actually works since it's a linear equation. Any combination of y's and x's. I just randomly chose those 2. So my y2 is going to be 10. Then I need to minus my y1. So my y1 is negative 5. So that's going to end up being a positive. That's fine. My x2 is negative 4. And I need to subtract 6, my x1. All right, so that's going to end up being 15 over negative 10. So simplify that, negative 3/2. So I'm looking at A, and I'm looking at B right now. Now, that's my M. I need my B. So what I want to do here is I want to write y equals mx plus b. And I want to solve for b by substituting my y. Let's pick that 7 for my y. I just figured out my m is negative 3/2. Let's pick this negative 2 for x, just because I haven't used that one, and then plus b. All I need to do now is solve for b. Okay, so my biggest issue is this right here, right? So you can simplify that. That's going to end up being a negative 1. So negative 3 times negative 1, it's going to end up being 7 equals 3 plus b. Subtract 3 from both sides. B equals 4. So put all this together, I'm going to get y equals negative 3/2 x, and then my b is positive 4. Right, so my answer there is going to be that b. So let's see how we did as a state. So as a state, we did pretty good here. 76% of the students in Texas chose the correct answer. This is actually our second easiest problem in the entire state. So we started the test out with kind of an easy question for the students. Some of these incorrect answers, you notice that the issue here was with flipping the slope. So that comes if you wanted to do those two, right? You would end up doing the change in x over the change in y. If they flip that, right, obviously it should be the other way around. If they did that, that's how you end up getting your negative 2/3. So any student that chose C or D, they probably calculated the rest of it correctly, but they just chose the incorrect formula for the slope. Problem number 2 asks students to solve a problem around rate of change. This is TEKS 8.3b in the second reporting category. This is also a readiness standard. So we have a graph here of a water level in a tank, and it's changing at a constant rate. And so they give us the x and the y, the x being time in hours, the y being water level. So this is a drag and drop. So we need to move the correct answer into each box. Obviously, not all answers will be used. So how can we describe the water level here? And if I were to take these numbers, you'll notice that it's impossible for me to move these numbers. So I need to either choose decreases or increases, and then I can't choose either of those two options for the last box. I have to choose either 0.25, 1, or 4. So it does help you in that way. And so hopefully we can see just visually from this graph right here, we can see that it's decreasing. So that should be our first easiest point. This is a 2-point problem. Now, how much is it decreasing? Now we are going to need to do a little bit of calculation. We are needing to calculate the slope. And if we go to our linear equations, our slope is going to be that m equals change in y over change in x. So let's just grab 2 points off this graph. We're looking for 2 points that look like they're on integers here. So I'm seeing this right here, right? That y-intercept of that x of 0, y of 9, and that looks pretty good right there. X of 4 and the y of 8. So you get a few different options here, so we can manually calculate that here. So let's make this our x1, x2, and our y1. Always label those correctly. And our x2 and our y2. So then our y2 is going to be 8 minus our y1 is 9. x2 is 4 minus 0, so that's going to be negative 1 over 4. Okay, so that's going to be negative 0.25 to make it as a decimal. So this also validates that negative means a downward slope. Now, you can calculate it that way. Some of you might realize that it is simply rise over run. Right, so you look, what is the change from these 2 points? The change in x, or the change in y first, that's going to be a minus 1. And then since we've got that graph, we can say, well, it goes over, or the run, 1, 2, 3, 4. So it's negative 1/4. So either way, you're going to get that right there. And so this is the correct answer. Decreases at a rate of 0.25. Now let's see how we did in the state of Texas. So this was 70% of the beep. So this problem also was fairly easy. This was tied for the 7th easiest. And as you can see, we had 70% of the students receive full credit. That's, remember, 2 points. They both got decreases and the 0.25. Another 27% got partial credit, so that's going to be 1 point. My guess is that most of the students were able to easily grab these decreases, and no credit means they didn't get either the decreases or the 0.25. Now, the decreases and increases, that's pretty self-explanatory. How are we getting this 0.25? Well, 0.25 is 1/4, right? If you flip that, right, if you do the change in x over the change in y, you're going to get this 4. So once again, if they took the slope formula and they just flipped it upside down, you would get this 4. So for problem 3, we are looking at solutions, graphs, and quadratic functions. This is TEKS A.6c, and this is reporting category 4. So we have a graph of a quadratic function, and we just need to find the best function that represents this graph. So if we open up our reference materials, go to our quadratics, we'll notice that this is in standard form. Now here's the tricky thing. One of the ways that you can solve this is not even listed as one of your forms. So there's a few different ways to solve this. The way that I'm going to choose is, since it looks like we've got 2 solutions here that are really, really easy, right? So we've got a solution there at x equals 1. We got another solution there at x equals -3. When I say solutions, I'm talking about where this parabola is going to cross the x-axis, so that y equals 0. And so when I'm seeing that, I'm going to be thinking of my factored form. So the factored form is not listed as one of the forms, but it's a very useful form. So it's the y, or in this case we're going to use the h of x, equals x minus u, and then it's going to be x minus v. Now this is helpful because that u and the u and the v, those are going to be my solutions. Okay, so I can say my u is going to equal that 1, and I can say my v is going to equal that negative 3. So I can substitute in this right here. Now this a is just a multiplier that sometimes you have, so we'll deal with that in a second. So x minus, and then it's just going to be x minus 1 because I'm substituting one of my solutions in there for that 1. And then x minus my other solution is negative 3. So that's going to end up being a positive 3. Now I need to go ahead and multiply this out. So this is going to be a, and we're going to make that a positive, right? So this is going to be x squared. Let's FOIL this out here. Plus 3x minus 1x minus 3. So what I have here is h of x equals that multiplier a times x squared plus 2x minus 3. Now, even though this is one of the answer selections right here, this is a, but I still don't know what that multiplier is. So I need to substitute a point. Let's go ahead and just substitute in that negative 4, right? That negative 1, negative 4, let's substitute in the vertex since that seems like a pretty good point. Okay, so my y value is going to be negative 4 equals a, and I'm going to just substitute in negative 1 plus 2, negative 1 minus 3. I'm just going to solve for that a. So this is going to be negative 1 squared, that's 1. It's going to be a minus 2. It's going to be a minus 3. So that's going to be a negative 4 equals negative 4a. All right, so my a equals 1, which means that's just going to drop away. But sometimes it doesn't, so we always have to solve for that a. So that does mean that my correct answer here is going to be a. Let's see how we did across the state. So this was also a fairly easy question in the state. You saw that 74% of students chose the correct answer. The incorrect choices were kind of spread out amongst B, C, and D. All of them included some type of sign error, right? So here's the factored form that we need to remember, that h of x equals a, and then x minus u, x minus v, and those are two zeros right here, right? And that resulted in that x minus 1 and x plus 3. Since that's a negative 3, it's two negatives make a positive, right? So these incorrect answer choices, you see we have the 1 and the 3, but we're just making sign errors. Like we are having flipping both positive 1, negative 3. We're going to flip the positive 1 but keep the positive 3, or we're going to keep the negative 1 and swap the negative 3 for the positive 3. So sign errors are usually going to be the issue for B, C, or D. So for problem number 4, we are working on linear equations and the distributive property. This is TEKS 8.5a, reporting category 3, and this is a readiness standard. Now the most difficult thing with this problem is trying to figure out what they're asking you to do. So let's take a look here. We have a rectangle with a length of 5 plus 2x inches and a width of 10. Triangle's got a base of 30, height of 4x minus 10. Okay, so the area in square inches of the rectangle is equal to, so the area of the rectangle is equal to the area of the triangle. Okay, so if you can pull that out of the problem, then you're good. The area of the rectangle equals the area of the triangle. The problem is if we're looking at our reference materials, you're not going to see the formula for area. They took that off, and we're just dealing with typical equations. So we have to remember that the area of a rectangle, right, is going to be base times height. The area of a triangle is 1/2 base times height. So now we start substituting. So a length and a width, we can use that as base times height. So my area of my rectangle is going to be 5 plus 2x And then let's multiply that by 10. Right, so we are going to need to distribute this out because that's what the standard is really testing, the distributed property. And then my 1/2, got a base of 30. And then my height, of course, is going to be something I need to distribute out, 4x minus 10. So I'm simplifying. I'm trying to solve for x. So let's distribute this out. So it's going to be 10 times 5 plus 10 times 2x. I'm going to go ahead and just simplify that to 1/2 of 30 is going to make 15. So that's going to be 15. Then I'm going to distribute out this 15 to both of those. 4x minus 15 times 10. So let's just simplify. I've got 50 plus, that's 20x equals 60x minus 150. Solving for x. So let's bring that 20x over to the right side. We'll do that one step at a time. So 50 equals 40x minus that 150. I'm going to add the 150 to both sides. Let's move that over there. And I'm going to get 40x equals 200. Now I just divide both sides by 40. X equals 5. All that work for something that's not so simple. My answer here is D, and let's see how we did across the state of Texas. So this was the 4th hardest question in the entire test. Take a look. Only 22% of the students got it correct. And this is a multiple choice. We're not even talking about a new item type. Those are kind of difficult as well. So look at the distribution pattern here. For the most part, we are really close to about a quarter of the students choosing each of these 4 answer choices. So to me, this just means we're guessing. Across the state, most students probably had no idea how to set this up. And so the answer distribution really makes me think that there was a lot of guessing going on. The key here is the area of square inches of the rectangle. So area of the rectangle equals, right, the area of the triangle. Because once you set that up, and then once you put in your formulas and substitute it in, the distributive property is not that uncommon for students. It's the matter of just setting this up. So this would be one in which we need to really work on how to write an equation from a real-world problem situation if the equation is not explicitly given to you. So for problem 5, we are working on factoring trinomials. This is TEKS A.10e in reporting category 1. This also is a readiness standard. Now, we're just looking for one factor of this trinomial. What makes this a little bit more difficult is they're only asking us for one factor. Sometimes they'll give you a problem and they'll say which 2 factors work, and you can kind of cheat by just multiplying all of the factors to see which one ends up with your trinomial. Can't do that here because there's 2 factors and they want us to only identify one. So there's a few different ways to solve this. I always prefer the diamond method, so we need to get students used to this if they're going to use this, right? We're going to take our A and our C, we're going to multiply that, and then we're going to find our B down here. Now, if possible, can you factor something out? And you actually can factor out a 2 out of all of that. So if we factored out a 2, right, and just divided all those by 2, it's going to end up being 2 and then 15x squared minus 2x minus 8. Right, so now this is going to be my A, this is my B, this is my C. So to make it a little bit, you could do it without, but to make it a little bit easier, let's go ahead and just factor out that 2. So my A times C, right, is now going to be my negative 120. All right, that's my A, 15. My C is negative 8. My B is negative 2. So I'm looking for the factors of negative 120 that add to negative 2. And so since it's going to be negative, I know that one of them is going to have to be positive, one is going to have to be negative to come up with a negative factor. So I'm just looking at the difference here. I need a difference of 2 between factors of 120. And I'm just going to kind of work through them here. 2 and 60, 3 and 40, 4 and 30. Let's see, that's going to be 5 and 22, 5 and 24. let's see, 6 and 20, getting a little bit closer. That's the 8 and 15 that I used to get there. And then, there we go. Finally found it, my 10 and my 12. So if I have a negative 12 and a positive 10, that multiplies to negative 120, that's going to add to negative 2. So what we do here is we write our a term, right? So our a is going to be 15x over one of our factors. That's going to be a positive 10. And then our a term, 15x over our other factor, negative 12. Now, we do that because it's possible to simplify. Can you simplify this as a fraction? Sure. You can divide both those by 5. That's going to end up being a 3. It's going to end up being a 2. You can simplify this, divide them both by 3. That's going to be a 5, right? And then that's still going to be a negative, but it's going to be negative 4. So we can take this and say, all right, we're going to take this as a first term in our binomial, 3x, and that's a positive 2. So that's one of our factors, right? We're still going to have to keep that 2 out there. And then our 5x minus 4, since that's a negative 4. And we see this 5x negative 4. We're kind of dancing all around it here, but we've got that 5x negative 4, and that is one of our factors. So our answer here is C. Let's see how we did across the state of Texas. So this was tied for the 26th most difficult, so right in the middle of the pack. 52% of the students across the state chose the correct answer, C. So this, remember, was the correct way to factor this expression. And you'll notice that the two most incorrect answers were really close, right? The 5x plus 4 just had a sign change right there. 3x minus 2, another sign change. So students probably set this up correctly, got really close, and then just made a simple mistake to make those sign errors. So on to number 6, we are looking at calculating correlation coefficient. This is TEKS 8.4a in reporting category 2. Now this is a difficult one because we are going to have to use a calculator, and there's a little bit of a pathway to get where we want to. So hopefully we notice as we're reading this problem, we have a table, seems like random data. It's asking for correlation, and they do tell you it's a linear association. We're looking for the strength of linear association. So once we find it, we're going to have to interpret it. So let's first at least find our correlation coefficient. So we're going to open up our TI-84 calculator. First thing we want to do, since we are using a regression model, we want to go ahead and hit the second catalog. We want to turn our diagnostic on. That's going to help us calculate it correctly. So let's scroll down to the D's. And we're going to make sure our diagnostic is on. We'll hit our enter. Hit enter again. It says done. Okay, good. Now we're going to hit stat. So we're going to enter in the numbers on the left. Those are our years. Those are going to be our list 1. So what we're doing here is we're just trying to calculate how strong is the relationship between the number of years and the number of species added. And it's going to range from -1 to +1, -1 being a 100% weak or 100% inverse association where one increases and the other decreases, and then a +1 being a 100% strong correlation where they're tied together. As one increases, so does the other. And then a lot of times your regressions will end up showing you a correlation that's kind of weak, right? So we'll interpret that in just a moment. So now that we've got our two lists, we want to make sure that we've entered them in correctly. So we're going to hit that stat again. Now we're going to hit over 1 and hit calculate. We're going to go down to that linear regression. And now that we have our diagnostic on, we're going to find that R right at the very bottom. So that R equals negative 0.09. And it looks like that's about as far as they're wanting us to get. Okay, so that's about as far as we've gotten right there. So that's step 1. Now we need to interpret it, right? So first off, I am at least seeing this, and I'm seeing this, okay? So I know it's not A, I know it's not C. But now we need to interpret this. Okay, so this is what I was talking about earlier. So think of your linear regression like this. Okay? If you get a 0, like there's no correlation. There's just nothing there. -1 is that strong negative. +1 is that strong positive. And that's where they fit. Okay? So we have some cut points here at -0.7, +0.7. All right? So these are all negative. These are all positive. Anything between 0 and -0.7 is going to be weak. Same with 0 and +0.7. Those are weak. It's only when you get past the 0.7, either positive or negative, you're going to get strong. Positive, strong, negative. So where does this fall? This falls right about there. It's very, very weak. There's not much of a relationship between the two. So we are going to give us our answer here of B, the weak negative correlation. Let's see how we did across the state of Texas. So we see here that this is tied for the 16th most difficult question on the test. Only 40% of students across the state actually got this correct. And the fact that we see that the incorrect answers here are distributed fairly evenly here, right? A lot of people, if they're going to choose an incorrect answer, they're going to choose this one because 0.91 is a strong negative correlation, but you'd have to do the calculations to see whether or not that's incorrect. So most of us were able to recognize that this right here is not a strong negative, right? This is a weak negative, and this is not a weak negative. It's actually a strong negative. So most students were able to see that these two don't match up. But you have to do all of that work that we just showed on the calculator to at least figure out what's the actual correct R. Is it -0.91 or -0.09? And so that's probably going to be just a little bit of guessing happening here because we've got a fairly even distribution across the incorrect answers. So for number 7, we are looking at the domain and range of linear functions. This is TEKS 8.2a in reporting category 3, and this is a readiness standard. So we see here we've got just part of a linear function, right? Linear function meaning it's a straight line, and we're looking for the range. So just a few clue words here. Linear means it's a line, right? You see the word line in there. And range, so we need to know the difference between the domain and the range. So if we don't know the difference between the domain and range, that's going to mess up our answers. So those two terms are not on the reference materials. So your domain is the set of all independent variable values. And most of the time, those independent values are going to be your x values. And the range are going to be the set of all possible dependent variable values. Now, this can be, typically when we're looking at a graph, we'll call it the y values, but sometimes it's f of x, g of x, h of x, things like that. So we're looking at range, which means we need to look at the y, okay? So we're going to look from, this goes from here to that 2 to that -4, okay? So that's what we need to see here. So we can say our y is going to be, the maximum value is 2, so we can say less than, but see how it's a closed circle right here? That closed circle means we're going to include that 2, okay? Less than or equal to 2, and we can also say it's going to be greater than, and I'm just going to leave it as a greater than because it's an open circle. Open circle means we do not include the number, so it's going to be less than or equal to 2 and greater than 4. Now let's see what we have here. I'll leave that right up there so we can see it. All right, so we've got an inline choice here. So really it's a 2-point problem. It's like 2 multiple choices. Sometimes the inline choices only have like 2 options, but we've got 4 options for each. All right, so set of all real numbers is, I wanted to say greater than or equal to. What is it greater than or equal? So this is the greater than or equal to side. This is the less than or equal to side. Okay, so this right here is my greater than or equal to. And we do it like this so you can write it in a line. Really, if you want to write it like this, you can do that as well. So greater than, not greater than or equal to, just greater than -4. And then here's my less than right here. Less than or equal to 2. Okay? And I'm going to have to move that. There we go. So greater than -4, right? So it's going to move above -4 here. There we go. Double check. It's greater than 4. That -4, and it's less than or equal to 2. All right, so those are our answers. Let's see how we did across the state of Texas. So this was tied for the 9th most difficult question. This is a 2-point problem, so only 33% of the students, 1 out of every 3 students, was able to get full credit, get both points. Partial credit, just 1 out of the 2 points, 44%. So if you put those two together, that's 77%, but it is a 2-point problem. There's a full 22% that got neither of them right. I think one of the difficulties here, first off, we have to understand what is range, and we're asking for range and not the domain, right? Because if we look at the domain, we look at the x values, right? Now we're getting into this greater than or equal to -2. You see that option right there? Greater than or equal to -2. That is going to be your domain if we're looking side to side. So the domain options are there. So if you're confused between domain and range, you'll get that wrong. And then also I think there's just difficulty of, greater than -4, right? Sometimes translating what we're used to writing in symbols, even to words, is just an extra step that allows for errors. So as students are working on identifying the domain and range of any type of function, I would highly suggest not only writing it in symbols, but taking the time to have students write it out in words as well, so they can get that practice of translating from symbols to the word form. Now we are looking at number 8. This concept is looking at the zeros of quadratic functions. TEKS 8.7b in reporting category 4. And we're just looking at a statement that needs to be true about this quadratic function here, and they're asking about the zeros. So we're looking specifically as what are the zeros, or what are the solutions, the x values that make f of x, right, equal 0. And if we wanted to, right, we could use our ax squared plus bx plus c. We could do our diamond method. We could do all of this. That would help us find our zeros, right, if we do all that. But the way this problem is designed, they're actually wanting us to do something else. So let's look at that. What they're wanting us to see here is that this is actually a perfect square trinomial. So what do I mean by that? Well, it's going to be that first row right there. Really, it's that second statement that we're looking at. Okay, this a squared minus 2ab plus b. Because what they're wanting is to recognize that 4x is a perfect square, right? If you take the square root of 4x squared, you're going to get 2x. So I can rewrite that 4x squared, right, as 2x squared, right? Take that squared. 81 is also a perfect square, right? It's a 9, okay? So if I see it in this format, that means it's going to equal this a minus b squared, right? So here's my a, here's my b. So really what this is going to equal is going to be this 2x minus 9 squared. That's what they're wanting us to recognize, that perfect square trinomial. And if that's the case, well then, first off, this is the only one that has, the 2x minus 9 squared. And then that 9/2 is going to work, right? You put that 9/2 right there because that's just going to cancel out, make it 9 minus 9, 0. That's what we're looking for. So our answer here is D. Let's see how we did across the state of Texas. This is the 28th most difficult problem in the test. Only 53% of the students, slightly above half, got right. And take a look at the distribution of our incorrect answers here. 13%, 17%, 17%. So most likely this is just guessing, because it's a pretty even distribution, which means students need to work on recognizing perfect square trinomials, right? That's the first thing that you're going to see in the reference material. So working with identifying perfect square trinomials, you could obviously solve this with the diamond method, but that takes quite a bit of work. But recognizing these perfect square trinomials, because it seems like students either recognized it and did it correctly, or they had no clue and they just guessed on A, B, or C. So looking at number 9, this is TEKS 8.9D. We're talking about graphing exponential functions. Reporting category 5, this is a readiness standard. So it looks like it's pretty simple. We need to find the equation of the asymptote of the graph, and they've given us the function here. Now, this is a drag and drop. It's a 2-point question, 1 point for each box. Notice that the x and the y can be placed in either spot. Okay, so sometimes they will restrict some of these to, one spot or another, and then same with our numbers, right? Our numbers can be in any spot here. So it really is wide open. There are multiple options, and they're not restricting you to an x or y being in the first or the second box. Though it does look like we're probably going to have an x or a y in one box and a number in the other. So we need to find the asymptote. Well, here's the thing. This term asymptote is not defined for us in our reference materials. And it's literally just asking, really, do you know the definition of this asymptote? Because if you do, well, then it's probably not going to be that difficult, right? So this is a line that a curve approaches, but it never reaches, right? So it approaches it infinitely. And you're going to see this with exponential functions. So the easiest thing to do here is let's graph this. Let's open up our calculator. You can choose either one, right? I'll just use my Desmos here. A little bit easier to zoom in and out because I want to show you what the asymptote is. So we are going to just graph this the way they want us to. So y equals, then I've got my 16, and then it's going to be 0.75 inside. And then I need to exponent that up, and there's my x. Okay. So let's figure out what we got working here. Okay, so we see this exponent graph. So you see how it's moving up, right? And it's slowly moving to the left, right? So as it moves up, it's slowly moving to the left. So we're going to say that infinitely, right? As it crossed it looks like it crossed the x-axis there, or the y-axis there, around 16 or so, and it is moving left. But look what happens as it approaches. It crosses that y-axis there, but look what it's happening is it's approaching the x-axis. Okay, so it looks like it touches. Like look at 25 right there. X value 25 looks like it touches, but as I zoom into 25, it doesn't quite touch. If you move from left to right, it's actually getting a little bit closer. Okay, so what if I move over here? Okay, let me just move over to 70. Right, looks like it's touching, but as I zoom in, look what happens. It's not quite touching. Now, I'm having to zoom in a lot more, right? But look, we can finally see, right? Look at the y value, right? They're having to give it to us in scientific notation. But if I zoom in, it's decreasing a little bit. Guys, you can do this as much as you want to. It is never, ever going to touch that x-axis. That is the asymptote. Okay? So that is the line that this curved exponential graph is infinitely approaching but never quite touching. Because you can go all the way over here to 360, and if you zoom in far enough, you will see that it's not quite touching. Now, that's the x-axis. We could do all that, recognize it, and still get this wrong if we don't know how to properly notate that. So this is what basically we had a drawing of, right? It crosses right around here, and then it looks like it gets close right there. So what is the line of the asymptote? Well, the line of the asymptote is that line that it approaches. And right now it looks like it's really It's that x-axis. So what is the equation of the x-axis? Well, a straight line is just going to be a straight horizontal line, right? It's going to be y equals something. If it happens to be a straight vertical line, it's going to be x equals something. So what is the y value that satisfies every x value? Well, it's the x-axis. Therefore, it's y equals 0. That's the answer we're looking for. And you can say y equals 0. You could say 0 equals y. You'd still get it correct, but that just looks weird. So we'll say y equals 0. Let's see how we did across the state of Texas. So only 14% of students got full credit. They got both points. This makes this second most difficult in the entire test. Now, 59% of the students got partial credit. So if you add those up together, you're going to get, about 73% getting 1 point or 2 points. But we're looking for this full credit right here. If you're going to get partial credit, you only get one of them correct. And I'm guessing a lot of students misidentified this x-axis right here. Since it is the x-axis, I could see a lot of students confusing this and saying that x equals 0 since we're dealing with the x-axis. But the focus here is, since it's a horizontal line, the x value is going to change, right? The x value is going to be infinite. We're looking for what is the y value that is consistent. So if it's on the x-axis, we're looking at a y equals, just like if we were looking on the y-axis, right, we would be looking at an x equals 0. So that's the confusing part right there. But that's what makes this so difficult, is you have to interpret this, you have to graph this, you have to know what asymptote means, and then you have to plug in the correct equation. So for number 10, we are looking at the laws of exponents. This is TEKS 8.11b. In reporting category 1, this is a readiness standard. And there is a big chunk of our reference material, look at that right there, devoted to the properties of exponents. So we just simply need to identify an expression equivalent to that x to the 3/7, right? And then having that squared. So hopefully we recognize, let's expand this out here, that what we're looking for is we're looking right here, this power of a power. So we need to correctly identify what this is. Even though it's a 3/7, x is being taken to a power, and then that power is being taken to a power because it's being squared, right? So x 3/7, that's taking it to a power. Then taking the power to the power goes right here. What do? Well, we multiply the two powers. So that's all we're going to do, right? So x to the 3/7 times 2. That's exactly what the reference materials tell us to do. To make it easy, we can go like this, right? You can make any whole number a fraction by putting it over 1. Multiply straight across, x to the 6/7. That's it. So we are looking at C right there. That is our correct answer. Let's see how we did across the state of Texas. This is actually the 13th most difficult problem on the test. And you can see more people chose A, the incorrect answer, than they chose C, the correct answer. Now, if you're looking at A, you're probably saying, oh, I get what they did, right? So the incorrect error here is you take your x to the 3/7, and when you multiply it by 2, what they did is they just multiplied the top and bottom by 2. So they doubled both the numerator and the denominator, right? And so they got that 6/14. But we have to look at the properties of exponents, right? A to the m, take that to the n power. When you have the power of a power, you end up multiplying the two powers, a times n, m to the n. And when you multiply 3/7 times 2, you don't multiply by 2 over 2, because if you do, that's 1, and that's not 2 anymore. So that's just an incorrect application of multiplying a whole number by a fraction. Pretty simple multiplication error here. Now, how do we get 17/7? Well, honestly, they probably added, right? They looked at 3/7 plus 2, and they're like, well, I can't add that because 2 is not a fraction, so I'm going to rewrite 2 as a fraction with 7 as a denominator. So look at that. They got 14/7 because 2 equals 14/7. They got x to the 17/7. Too much work for an incorrect answer. And then, right, what do we have here? They're adding again to the 3/7 But they're literally just saying, I just want to add the whole number to the numerator and say 3 plus 2 equals 5, which doesn't make a whole lot of sense. So I get why A is an incorrect answer. B and D don't make much sense. But you can recognize everything that you're supposed to do and still get it wrong with A if you inappropriately multiply a whole number by a fraction. So that's something that we definitely need to work on with students as we are continuing to practice these laws of exponents. So for problem number 11, we are looking at quadratic domain and range. This is TEKS 8.6a in reporting category 4. This one is also a readiness standard. We're looking at a quadratic function here. And what we need to do is we need to look at the domain and range. Now, unfortunately, like has been all throughout this test, these are not defined for us. So we need to know that our domain, those are going to be our x values. Those are our independent variable values. And then our range, we need to know that our range is going to be our y values, our dependent variable values. That's going to be very helpful for us. But let's go ahead and just open up a calculator here. And you see we've already got that graphed for us here. The 5x squared minus 20x plus 12. I went ahead and entered that before. And so let's see what this graph looks like here. So if we zoom out, we're going to notice that it expands to the left and the right very slowly, but it infinitely expands to the left and the right. So my domain, my x values, it's going to be infinite. What I can talk about here are my y values. And we see down there, the y values reach down and then they bottom out the vertex, the minimum value is at 2, -8. Okay, so I could do something with that. So let me just draw that for us real quick here. So right about here, we'll say that's 2, -8. It doesn't matter if it's perfectly representative or not. I'm looking for that 2, -8. So now let's take a look at this. Domain of the function is x is greater than 2. Okay, well, no, because the domain member is infinite, right? It goes infinitely from side to side. So that's incorrect. The range of the function is x. N of x is greater than or equal to -8. Well, there's my -8. The range member is, up and down. So it's saying it's greater than that. Okay, that makes sense because it's not going to be less than -8. It picks the bottom part of our vertex and it moves up. The domain, no, we're not going to restrict the domain. So C doesn't work. And then the range of the function is x is less than or equal to -12. Well, this picture doesn't show it correctly. If we actually look at the calculator, I'll tell you where they got that 12 from, right? It's actually the y-intercept. So my picture wasn't that good. But if you look right there, look, that's the y-intercept. So that's where that -12 comes in. But we're not going to use that as a range. Our range is going to be restricted based on the vertex, not the y-intercept. So my answer here is B. Let's see how we did across the state of Texas. So this is the 23rd most difficult problem. Less than half of the students actually got this correct, 47%. Now we see 17%, 11% for A and C. These are the two that deal with domain. My guess is that a quarter of the kids, full 25%, chose D, probably because they see a 12 right there, and they see a 12 right there. And they know that, well, in slope-intercept form, right, y equals mx plus b, that tells you what the y-intercept is, and that has to do with the range. Obviously, this isn't a linear equation, so the y equals mx plus b is not going to be appropriate here. But they probably recognized range was important, and they just grabbed a 12. So what we need to do here is make sure every time we have the ability, let's graph it. Let's visually look at it, because then if you visually look at it, you're going to see that 12 doesn't show up anywhere except for the y-intercept. So for number 12, we are looking at writing inequalities. This is TEKS 8.2h in reporting category 3. This is a drag and drop. There are 4 different options here. We need to write an equation or an inequality here, but honestly, look, it does tell us right here It does tell us to write an inequality. So if we recognize that, we should automatically knock that out. Now let's go ahead and take a look. We've got places for coefficients before the x, before the y. You see these greater than or equal to signs, they can only go right here. So the only thing that can go in that third box is a greater than or equal to sign or a less than sign. Because if I'm going to try to drag any of these signs here to any of the other boxes, they're not going to work. So we are restricted, and you can't actually drag a number into that third box. So that the number has to go in the first, second, or the last box. So let's take a look at our problem here. We do know that it's an inequality, so we're not going to use the equal sign. So we're ordering hats, we're ordering t-shirts, we're going to get free shipping if it's over $100. Okay? Now, they give us all the information we need. Hats, X. Okay, so hats equals X. T-shirts equals Y. Okay? And look at that. The hats cost $7 each. All right? So what we're going to say is we're going to say 7, since that's our hats. All we have to do is match that up with the correct variable. So 7x. And then we want some t-shirts. Those are $10 each. Match them up with the correct variable. That's y. Now, it needs to be over $100. Okay? So when we're buying multiple things, we do need to recognize that we're adding. That's already given it to us. We don't have to worry too much about that. So really, it's this over. What do we do with this over? Over is simply going to be greater than. So that's it. Just taking a few sentences and turning it actually into something. We want it to be 7x plus 10y is greater than the $100. So let's make sure we get that right. 7x plus 10y is greater than 100. Let's make sure we got that in correctly. Yes, we did. All right, so that's the answer for this one. Let's see how we did across the state of Texas. So this was the 13th most difficult problem. So it is pretty difficult. I don't think there's anything super tricky about the problem itself. It was just the fact that it was a drag and drop with 4 possible entry points here. We only had 38% of the students get full credit, get the full 2 points. Partial credit, we had 46%. So if you put those two together, right, we're looking over 80%. So that's pretty good. 16% got no credit. That means they got 0 or 1 item correct. So I would say if you were to combine these together, this would make this a fairly easy problem, but there's a lot of moving parts here. And I would probably guess that most students got the 7x, the 10y, and the 100. We don't have the data broken down, but I'm thinking it's the sign might have caused a little bit of issue there. That's the one that might mess kids up. So we need to focus on identifying terms in the problem that gives the best clue as to which inequality to use. For number 13, we are looking at real-world quadratic functions. This is TEKS 8.8b in reporting category 4. So we have an experiment here, table of data, and they've given us x and y here. So we've got the x is the speed, we've got our miles per gallon as our y, and we need a quadratic function that can best be used to model the data. So we know quadratic functions are parabolas, either they're going facing up or they're facing down, right? And so take a look at this. We see the y here. It's moving up. It's moving up. It's moving up, and it kind of hits my peak here and then goes down and then goes down. So it looks like it's kind of a downward facing, kind of like, that's going to be my vertex would be if I were to graph this, right? Looks like it's going to be a 40, and that's a 30.1. Now, what I'm looking for is 65 miles an hour, okay? So it is moving down, so, we could guesstimate this is like 28-ish, but we don't really want to ish this one. That 27.9 looks good. But how do we do this for real? I'm thinking maybe it's A. How do we do it for real? Well, let's do this. Let's open up our calculator. We're going to use linear regression. So we're going to use our TI-84. First thing we need to do is we need to go to second catalog. We're going to scroll all the way down here, and we're going to go to our D's. We want to make sure our diagnostic is on. We do this whenever we do our quadratic regression or linear regression. Since this is a quadratic, we are going to use a quadratic regression. I think I said linear regression earlier, and that would be incorrect. So we're going to hit enter, then we're going to hit enter, done. All right, so we're good. So what we do is we hit our stat button. We're going to edit our list 1 and our list 2. So our L1 is just going to be our x coordinates, 20, 30, 35, 40, 50, and then 60. Then we're going to enter our list 2, and all it's going to give us is it's going to give us something in standard form, the ax squared plus bx plus c. We're going to need that, and we're going to plug in our 65 as our x. So we're just trying to figure out what is our a and what is our b, and what is our c, 29.1. Okay, so we go back to our stat, and we go to calc. Now quadratic regression, we go right there, number 5. And we're going to calculate. All right, so let's see what they give us here. They give us, so A equals that, negative point 0.007337. B equals, I'm just going to write a whole bunch of digits here, 688666. And then my C equals 14.1153246. All right. So this is going to give it to me in that ax squared plus bx plus c. So I'm just going to go ahead and plug all that in. All right, let's plug this in here. And let me get that down here. All right, so we're just going to plug this in to our calculator, and let's see what we get here. Okay, so ax squared. So that a is going to be negative 0.007337, and then the x squared. Remember the x, they wanted us to calculate 65. So we're going to do 65 squared plus, and then my b here, right, my b is going to be that 0.68, okay? 666. 0.68666, and that's bx, right? So times x times my 65, plus, and then whatever that long c is, 14.11532. 14.11532. There might have been a little bit more after that. 46. Okay. 46. Let's calculate. 27.74. 20. So they're saying that my y equals 27.749. Let's see how we did. 27.749. We got really close. I didn't enter in every single digit. If I had entered all the digits, I would have gotten that exactly. But we were correct with our 28-ish. The answer is A. Let's see how we did across the state of Texas. So this was tied for the 18th most difficult. You see that we had 41%, just barely over 2 out of 5 students get it correct. And we had almost as much get it incorrect, right? And this, if we're just eyeballing this, that 31 is pretty close to 29. Obviously, if we were to analyze this, we hopefully would see that it's moving up, moving up, moving up. There's our vertex moving down, moving down. Even if we just did that basic analysis, that's something that's going to make that 31 not seem correct. Obviously, that takes a lot of work to use the calculator, use linear regression. So students need extra time practicing that and calculating multiple times so they're comfortable moving in and out of that on their TI-84 calculator. For number 14, we are looking at writing exponential functions. This is a readiness standard, TEKS 8.9c, reporting category 5. So we have a real-world situation here, and we need to write an exponential function. We know that not necessarily because they give us that term, but because we do see our answer choices here all are in this standard form of p of x, or y usually, equals a times b to the x, right? That's our standard form for exponential functions. So a is always the initial amount or the starting amount, population growth, or maybe you're investing money, that's your principal. And this is always your rate, your b. Now, it can be a growth rate if it is greater than 1. It's going to be a decay rate if it's less than 1. So sometimes it grows larger, sometimes it decays or gets smaller. And then your x is usually your time factor. So we just need to take this real world situation, put it into an exponential function. All right, so take a look at our answer selections here. Right, we see that we've got two different initial amounts here, the 48,000 and the 50,400. Take a look at this right here. It says our initial estimated is 48,000. So that's going to automatically eliminate two of our answers because that's our A term. So we're going to get rid of A and C. So even if we didn't really know what we're doing, if we at least knew that the A is the initial amount, that's part of it. Now we need our rate. I'm going to multiply it by the rate. Now the problem is they don't give us the rate. They do give us the x years, okay, so that's our time, but they don't give us the rate. Typically it's a percent, like 4%, 5%, but they do give us a clue. Take a look at this. It starts at 48,000, and after that it grows, so it moves up to 50,400, okay? So knowing this, we know it needs to be a growth rate because it's increasing. A decay rate makes it smaller, it's shrinking. So it's growing, so we need one of these fractions that's going to get us something greater than 1. And hopefully we're saying, oh, that's going to be it right there. That is actually going to be something greater than 1, and we see that because it's an improper fraction. So that's our clue right there. Now, that's also how we calculate the rate, in case you're wondering wherever they get those percentages, right? You take the year 1, you divide it by the initial, right? And then that's going to get either your growth or decay rate. So they're just giving it to us without the percentage. So this calculates the percentage. This would be a decay rate because this is going to be very small. It's a very, very tiny fraction, close to 0. So that's why that's wrong. So our answer here is A. Let's see how we did across the state of Texas. So this was the 12th hardest problem, and I really do think the fact that there was no percentage really messed students up. And you see, right, we got almost the same amount of answers on A and D, and those were the two that we should have had, right? The B and the C were the two that had the wrong initial amount. So at least we're recognizing that. But then we needed a little bit of reasoning because it seemed like it was kind of just an even toss of the dice there between A and D. We need to realize that this is a growth rate. So this definitely is a form of exponential functions that students need to practice with. What happens when you're just giving two amounts and you have to calculate the rate yourself? How do you represent that as an improper fraction? So for number 15, we're looking at graph transformations. This is TEKS 8.3e and reporting category 2. So we have the graph of function f of x equals x. We need to transform it. So what does that mean, f of x equals x? Well, take a look at all your f's right here. Right? You just got a slope of 1. Look at every single f line. Graphed correctly. Okay, so that means that if we wanted to, and I can use this connect line feature to make my own little graph here, right? F of x equals x. It's just your basic vanilla line, right? That's just going to go diagonally, slope of 1. That's the key thing to think about right there. Your slope equals 1. Okay, so slope f of x, slope equals 1. Now what happens when you say g of x is 3 f of x? Okay, well, this is a graph transformation, right? And so what we can do here is, first off, we might just know what happens when you have a multiplier right here, right? So when g of x, when you've got this a f of x, when you've got this multiplier in front of this f of x for graph transformation. It depends on what that multiplier is. Okay, so if a, the multiplier, is greater than 1, right, it's going to be a steeper slope. If it is greater than 0, right, but it is less than 1, right, then it's going to be a shallower. And then if it's just completely less than 0, right, then it flips. It becomes a downward slope. This is an upward slope, so we'll just deal with this right here. Okay? So we have a 3 right here, so that means we're going to be dealing with this right here. This a is greater than 1, so we're looking for a steeper slope. Okay, something that looks maybe something like this. Now, that's just knowledge that hopefully you learned, this year in your Algebra 1 class. If that doesn't work, we could also just plug it in a little bit. Look, if the slope of f of x equals 1, right? Let's just say we're talking about the slope of f of x, okay? Then g of x is going to equal 3 times f of x, 1. So the slope of g of x is going to equal 3. And so hopefully we know that it's going to be, up 3 over 1, up 3 over 1, up 3 over 1. That's a steeper slope. So if we look down here, the only one that works, right, that c is a shallower slope. So this is something that is, greater than 0, but, less than 1. And so what do we have working here? There we go. D. That's got that steeper slope. And that's exactly what we're looking for, that steeper slope. So that is our answer, D. Let's see how we did across the state of Texas. So this was tied for the 20th most difficult problem. And we see that our correct answer down here, D, only got 44% correct. The distribution of the incorrect answers between A, B, and C really kind of points to the fact that we have just some random guessing. So you either know it or you don't. There's not one incorrect answer that really stood out, right? A and B are both parallel, so maybe they're thinking, okay, I remember we need parallel slopes, so you need an equal slope, just a different y-intercept. But obviously that's not a parallel slope. So they knew something was happening with that slope. They just misidentified it as a parallel slope. And honestly, C would be one that would be a little bit closer to the correct answer. It was 1/3 of the slope rather than 3 times the slope, but at least it's dealing with a graph transformation rather than a parallel line. So 20th most difficult, it's just a graph transformation. There's a lot to remember here. So for number 16, we are dividing polynomials. This is TEKS 8.10c, reporting category 1. This has been a supporting standard since 2016. The first time this standard has ever been tested on the STAAR test, so it might have thrown a few people off. So what are we doing here? It looks like we're literally dividing, right, this trinomial by this binomial here. So there's a few different ways to do it, right? First, we're just thinking, okay, so 2w plus 1, right, needs to divide into that. Well, what we could do here is we could just diamond method that right there, right? ax squared plus bx plus c. So my a is going to equal 8. My b is going to equal -20. My c is going to equal -12, right? Or if I want to, I could save myself a little bit of work, right? You could, if you wanted to, go ahead and just factor out a 12, right? Or a factor out of 4, and that's going to end up being 2w squared minus 5w minus 3, right? Either way works. We'll just go with the original, because if you do that, you're going to have to multiply that 4 back in. So let's just diamond method like this, right? So a times b, so that's going to be 8 times -12, that's -96, My b is negative 20, right? So I'm looking for factors of 96 that multiply to negative 96, so that's going to mean one positive, one negative, and add to negative 20. Okay, so we're thinking, how do we get to 96? 1 and 96, 2 and 48. Let's see, 3 goes in there 32 times, getting a little bit closer. 4 goes in there 24. Okay, that's only, there you go. That's what I need, that's 20 apart. So I'm going to need to make that a negative 24 and a positive 4. So then what you do is you put your a, right? 8x over 4, ax, put your a over negative 24, you reduce if possible. So that's going to be 2x positive 1. And that's going to be x over, let's see, minus 3. Right, so we got a 2x plus 1. And then we've got that x minus 3. So for number 16, we are dividing polynomials. This is TEKS A.10c, reporting category 1. This is the first time this particular standard has ever been tested on the STAAR test, so it might have thrown a few students for a loop here. Now, what we can do if we want to is, since we're dividing this trinomial by this binomial, we could use, factor out a 4 here, right, and then make it 2w squared minus 5w minus 3, right? And then we can use the diamond method if we wanted to do that, but we're going to need to multiply that 4 back in if we do that. Another way that I think we might look at it is just long division, right? Think of what we do for long division. It's an effective way to do it. There's multiple ways to solve this. Watch this, 8w squared minus 20w minus 12. So if you want to do the diamond method, right, where you multiply a times c, then you add to b, that's fine. You could do that. But take a look at this. How many times can 2w plus 1, since it's a binomial, let's look at this binomial right here. How many 2w's can you fit into 8w squared? Well, I can fit 8 times 4, right? Or 2 times 4 makes 8. W times w makes that, because I'm trying to eliminate that, right? So 4w times 2w is going to be 8w squared, right? And the 4w times 1 is going to be plus 4w, right? Remember, and then we subtract these so that we end up flipping both of those, right? And that becomes 0. That's going to be a minus 24w minus 12. And so I'm trying to match that 2 into the minus 24, so that's going to be I just need a minus 12, right? So minus 12 times 2w is going to be minus 24w. And then minus 12 right there. And then remember, we subtract it, which means we flip all of our signs, and that's just 0. So there's my 4w minus 12. And just to double check, right, you'd want to go ahead and 4w minus 12, 2w plus 1. You'd want to FOIL that back out to make sure it does equal that right there, which obviously it does. All right, so my answer is B. Let's see how I did across the state of Texas. So this one was the 14th easiest problem. We had almost 60% of the students get it correct. You saw the most popular incorrect answer was very close. Had both parts of that binomial correct, just missed the sign. Since this was multiple choice, right, if you recognized that this was going to be a factor, you really could just brute force this and multiply 2w plus 1 by all 4 of those and see which one gets you this particular answer. So if you made this a drag and drop, I'm sure the percentage would have really drop, because then you would have had to construct the answer on your own rather than kind of double checking from the available answer choices. For number 17, we are looking at graphing inequalities. This is TEKS 8.3D, reporting category 2. This is a readiness standard. We simply need to graph this inequality. They've given us a nice graph there. And then we need to find which ordered pair is actually in that solution set. So how do we graph this? Well, let's just take a look at what they've given us. And we're just going to pretend we're going to deal with that less than or equal to. We're going to deal with that last. Okay, let's pretend this is in slope-intercept form. Y equals mx plus b. So my m is going to equal that 3/5. That's nice. And then my b is going to equal -6. Right? That's my y-intercept. So I've got a point right there. And then take a look. They've given us a slope of, remember, it's the rise, the change in y, over the change in x, the run. Right? So we're going to go up 3, 1, 2, 3, and then over 5. Okay. So there's another point. We're going to go up 3 again. That's right on the x-axis. We're going to go over 5 again. All right, so look, I've got, right, so that's my line. Okay. It is going to be a solid line because we're going to do a less than or equal to, which means we can include any dot that's on the line if we want to. Now the question, if this is which way do we shade? Okay. Well, let's pretend we forget which way to shade. Okay. So let's just take a look at our answer choice. So we've got a 5, -4. So there's 5, -4. I'm going to plot that right there as A. I've got a, what is that, -2, -5. Okay, so I've got my -2, -5. That's going to go right there. Now I got a 9, 1. So my 9, 1 is right there, just above the line. Those last two, B and C, are right above the line, barely. -8, 3 is nowhere near. Okay, so even if you didn't know that, yes, we are going to shade below the line, since it's less than, it is going to be below the line. I wanted to show you that, look, there's only one answer choice that's on one side of the line. The other three are on the other side of the line. So we're always going to choose the one that's off by itself. So our answer here is A. And if we want to, right, we can go ahead and plug this in, since this is an X and a Y, right? Let's plug that in to make sure it makes a true statement. So my y is -4. Is that less than or equal to 3/5 x, which is 5, minus 6? Simplify it, right? That's just going to cancel each other out. So -4 less than or equal to 3 minus 6 is -4 less than or equal to -3. Yes, it is. If you look on the number line, 0, here's my -3, there's my -4. It's less because it's farther away. So that makes a true statement. The other three would not make a true statement. So my answer here is A. Let's see how we did across the state of Texas. This was the 29th most difficult, which means out of 50 problems, right, it was kind of trending towards the easier side. But we just got a little bit more than half the students got this correct. You had multiple ways to solve this. I decided to graph it out. Students could also solve this just by doing what I did and just plugging every single x and y coordinate into there to see which one makes a true statement. You didn't even really need to use the graph. Multiple options to do that. And so this is the correct answer. And you see we've got a pretty even spread here. We're trending towards that B. It's kind of an even spread, so some students might not have worked it out, might have just kind of tried to eyeball it there. For number 18, we're looking at the domain and range of exponential functions. This is TEKS 8.9a and reporting category 5. So we've got this exponential function. Hopefully we notice it as 1 because it's in that form that we're so used to, right? That y equals a, b, and then we've got x as our exponent right there. So that's our clue that we're dealing with an exponential function. But it's not even asking us, what the initial value is, what the growth rate is. That's typically what we'll get when we're trying to identify the initial value. That's the A. This is your growth rate. Could be a decay rate, kind of depending on whether it's greater than 1, less than 1. We're just looking for, look, domain and range. There's nothing in that that shows us what the domain and range is, which means we need to graph it. And that's probably the difficult part of this problem is just recognizing there's only so much we can do until we graph it. So let's graph it. And let's see what we can find, because we're going to be able to eyeball it here. I'm just going to substitute that as a y rather than that p of x equals, all right, so negative 7 x, and then let's, actually the negative 7 is not, there we go. I would have messed it up. Let's make that a 4 to the x power. Okay. Let's see what we've got. All right, so we see that we've got, all right, so the asymptote right there, you see, is going to be that 0, right? It's getting closer and closer and closer and closer to the y equals 0 or the x-axis, but it's never closing. It does cross our y-axis, and it moves ever so slowly to the right, okay? Which means this is what this tells me, and I'll kind of do that right there. This tells me that we know that our domain is going to be infinite, right? Okay, the x values are going to range from, less than infinite, greater than negative infinity. Okay, the domain is going to go on forever, because obviously it goes on forever to the left, but over towards the right it does continue to expand. It's the range that's what we need to deal with. The range is the asymptote, right? It's going to hit that 0, so that's going to be, y is going to be less than 0, but it's never going to include the 0, so it's not less than or equal to. Okay, so y is going to be less than 0. Let's see which one looks like that, and there we go. The range is going to be all real numbers, but we can't put any boundaries on it. It's going to be that b. The range is all real numbers less than 0, because 0 was the asymptote that the curve was approaching but never actually reaching. So let's look at our answers across the state of Texas. So this was tied for the 9th most difficult. Look at that. Just a third of the students got it correct. And look at this distribution, right? That's close to 1 out of every 4. That's close to 1 out of every 4. So this is almost a pure guessing one, in which students are guessing. I'm sure some of the students that got B correct also were just guessing, though there were a few students that were actually able to open up. Here's the thing. Open up the calculator. Calculate and graph. Because if you can graph it, it's easy to kind of eliminate some of these answers, right? The range is not all real numbers. No, that would be the domain. So maybe we recognize that. But, this right here, we're just confusing domain and range. I don't know if students are struggling with domain and range, but they have to do that with linear functions and quadratics. So hopefully they know the difference between those two terms. But we just need to open up our calculator and graph and visually display that to identify the domain and the range. So for number 19, we are looking at attributes of quadratic function graphs. This is TEKS 8.7a. It is a readiness standard in reporting category 4. We have a basic quadratic here. 4 statements, only one of them can be true. So let's just look at them real quick. So the function has 3 zeros. Well, we need to know that these are our solutions, right? These are the x value that make f of x equals 0, which means these are, another way to think of them as our x-intercepts, right? So x-intercept, solution zeros, all synonyms here. I see 1, I see 2, not 3, so that's incorrect. The maximum value, right, that's going to be the highest value, and that is not at 3. That's right there at 4, so that's incorrect. The vertex of the graph is literally, they swapped the x and the y value. Now, I'm sure we had some people doing this, but look, this is the vertex right there. It's an x value of 1, y value 4. So they literally just swapped it. The equation of the axis of symmetry of the graph is, now this might be a term they might not be familiar with. Axis of symmetry, though. Think, what is a line that you can draw that you could cut this in half, you could fold it over, and it would be equal. It's right there. It goes through the vertex, and it's a vertical line, which means its equation is going to be x equals, and what is that x value? 1. So our answer is D. Let's see how we did across the state of Texas. So this was the 26th most difficult, right in the middle of the pack out of a 50 question test. We see that we had slightly more than half of the students get the correct answer. Most of us ignored the A and the B, but look what tripped up. Almost a third of the students taking the time to realize that this is not 4-1. 4-1 is right here. Realizing that an incorrect answer is going to just swap the x and the y values, because that's not even anywhere on the graph. So I think students might have been going a little bit quickly on this one, and they saw something they knew as a 4 and a 1. They didn't take the time to read all 4 to see that, D makes sense as well. They could have gone back to C and realized, oh, they just swapped those. So we got tripped up by just switching the x value with the y value. So for number 20, we are simplifying square roots. This is TEKS A.11a, reporting category 1. So what we have here is we've just got a basic expression here. Now what we're going to do is we're going to take that square root of 600, we're going to decompose it a little bit, right? We're going to think we need a perfect square, and we can kind of multiply it into the perfect square. We can list out our perfect squares, but most of us will say, look at that, we can break that into a 6 times 100, right? But we need to go ahead and just show it, rather than the 6 times 100, it's square root of 6 times the square root of 100 equals the square root of 600, right? Just, we have to keep the square root in there. We can't simplify the square root of 6, but we can square root this. We can square root 100 to say that's just 10. Okay, so it's the square root of 6 times the square root of 10, and then we end up reversing the order. It makes more sense to have the 10 on the outside, square root of 6 on the inside, and here is our answer, B. Let's see how we did across the state of Texas. So this was the 5th easiest problem. Look at that, over 70% getting it correct. You see A here, we just kind of swapped. We did it all correctly, and then we just swapped the 10 and the 6 different locations here. You could also get 600, right, if you do 24 times 25. It's not the most efficient because you would need to simplify it one more time, but that does equal 600. You see C and D are just different ways of 24 times 25, but they just pulled a number out of the radical without keeping it in there, and then so that's why it doesn't work. So our answer here is B, 5th easiest problem. So for number 21, we are looking at lines parallel or perpendicular to axes. This is TEKS A.2g in reporting category 3. So we just have this basic line graphed on a coordinate grid. We need to find a true statement, and so all of our statements here, you see, have 2 parts. We are going to be looking at the equation of the line and then the slope of the line. All right, so let's take a look at this equation, right? So if we're looking at this, it's sitting right on that -4, right? And we see that no matter what our y is, right, we can make our y 1, right? We're always going to have an x of -4, right? We can put it down there. We can say our x of -4, now y is -2. We have our x of -4. We have our y of -6. We can plot as many points as we want to. This is x of -4, now y of +6. We're always going to get that same x of -4. So that's going to be our equation. X equals -4. And it looks like that because the y value is going to be anything, right, continuous between positive infinity and negative infinity, but that x is going to be negative 4. Okay? Now, what do we know about the slope? Well, slope is the rise over run. So that's the change in y over the change in x. All right, so I'm going to go between, these 2 points right here. Okay? So I'll make that my x1 and my y1, and I'll make that my x2 and my y2. All right, so that's going to be y2 minus y1, x2 minus x1. All right, so my y2 is going to be 1, and my y1 is going to be 6, and then my x2 is negative 4 minus the other negative 4, because it just stays negative 4. Here's the problem. Those two negatives become positive. It ends up being negative 5 over 0. It doesn't matter which 2 points I'm going to pull. It's going to be over 0, and you can't divide by 0. You can't take 0 groups of negative 5. If you ever try to divide by 0, you're going to get an error message, which also means undefined. Okay? So we've got an equation of x equals negative 4. Our slope is undefined because it's dividing by 0. It's not changing left or right. It's simply going up or down. And so our answer here is going to be A. Let's see how we did across the state of Texas. This was the 6th easiest problem. 72% of students in the state of Texas got this one correct. There were 2 different things that could really help us get this. So you could have just focused in on that x equals negative 4. Right? So most of us are pretty good at whether it's y equals or an x equals. And then that slope is undefined as that vertical line. That's something kind of easy to remember. So we had 2 different pieces to this question to focus in on, and that really helped us. And you see our incorrect answers are kind of spread kind of evenly. So there wasn't one that really tripped us up. It was just you either knew it or you didn't. So for number 22, we are graphing functions and identifying features of those graphs. This is TEKS 8.3c, reporting category 2. This is a readiness standard. So we have a basic linear function. Look what it's asking. It's simply asking for the 0. Well, if we know what a 0 is, then this is going to take us about 3 seconds, right? So a 0 can also be thought of as an x-intercept. It can also be thought of as a solution. Here's really what we're looking for. What is x equals if you make f of x equals 0? So what is that x value to make f of x, or since we're graphing it, that y equals 0? Well, right there. When x equals 2, right, then f of 2 equals 0 because the y value is 0. That's what we're talking about. So the 0 of f, there it is. It's going to be 2. Our answer is C. Let's see how we did across the state of Texas. So this was the 3rd easiest question, or tied for 3rd easiest on the test. This is our 3rd relatively easy question in a row on this test. See, 74%, almost 3 out of 4 students chose that one correct. You see the number 1 incorrect answer there, -6. So this is just a vocabulary thing. That is not a 0. That is a y-intercept. So those are the 2 points that make the most sense of either picking a 2 or -6. If you do a -3 or 3, nothing is happening at either location. So we understand this is that y-intercept, and then we just need to know the difference between a 0 and a y-intercept. For number 23, we are solving systems of equations. This is a readiness standard, TEKS 8.5c, and reporting category 3. So a system of equations means we've got 2 different equations here, and the x and the y values are in the same system, which means at some point you could graph those 2 and they would cross. All right, so if you were to draw a graph, I'm not sure what these lines would look like, but let's say one goes this way, one goes this way. They're going to cross at some point. That's what we would call the solution, whatever that crossing point is. So how do we solve that? Well, we could graph each of them and try to find the crossing point. But a simpler way would be to just do it algebraically here, right? So since these equations are in the same thing, same system, watch what happens if I were to double that top row right here. We can double it and we can add it, right? So I'm going to distribute this out. So that's going to end up being negative 6x plus 10y equals 42. Now, why would I double that? Well, if I add those two equations, look what's going to happen. I doubled it because I wanted the negative 6x to cancel out my 6x. I need to eliminate one solution. So now I've got 10y plus a negative y, so that's 9y equals, and then that's going to be 42 minus 15, right? That's 27. So that's going to be y equals 3. Now, you got two options here. Right, we see just one answer right there. That has y equal 3. You could plug that 3 into either of those equations to get the answer, or, right, what we could have done is we could have changed the other equation, right? So let me show you that you could have done it either way. And rewrite the original equation here. I'm going to take this one, and I said a positive 5y, so I'm going to multiply that bottom one by 5. Because I want 6y minus y equals negative 15. I want to multiply that by 5. Now you have to multiply both sides by 5, because watch what's going to happen. And I'll do it up here on the top here. So that's going to end up being 30x minus 5y when you distribute this out equals negative 75. So you add those two together, and this is what you get. You get 27x. Those two cancel out, equals, and then we've got that 21 minus 75, right? So that's going to be a negative 54. Divide both sides by 2. X equals negative 2, which is our x value right there. So that's our solution. If you started doing it this way, right, you could just take your negative 2 and just plug it into either of the original equations, and you'd be fine to find that y. So our answer here is B, negative 2, 3. Let's see how we did across the state of Texas. So 68% of the students got this correct. This was the 10th easiest question. So it's not the easiest, but it's within that top 20% there. And you see from the distribution pattern of our incorrect answers that you either knew what you were doing or you were most likely just guessing, because this 12, 11, 9 is a pretty even distribution. So this is just a reminder of how to solve systems of equations. There's multiple ways to do it, and students just need extra practice with those. So for number 24, we are factoring trinomials. This is TEKS 8.10e, reporting category 1. It is a readiness standard. Notice it's multi-select. So if I select two answers, I cannot select a third. So it's only going to let me select two, and if I just select one, try to move on, it is going to say error. So new item type, I need to find two expressions here that are equivalent to what I have here. And so first thing we should see if we see this trinomial here, we should think factoring, right? We should think, wow, look at those coefficients. Look at that constant. Those are huge. I want to factor something out of that. That should be our first thought. They're all even. Let's factor something out. We should be thinking, I can get a 12 out of all of those, right? So if you divide all of that by 12, right, that's going to end up being 12x squared divided by 12 minus, we're just going to distribute this out here, plus 48 over 12. That's the same thing as this. You can divide that 12 into each term separately. So that's going to cancel out, right? That's just going to be x squared minus, that's just going to end up being a 4x. It's just going to be a 4 as well, plus 4. Now the 12 didn't disappear. We factored it out. Okay, so I've got one answer right here, that fifth option. Now, when we see this, hopefully our eyes are recognizing, you know what, that looks like it might be one of these right here, and it actually is. Take a look. I'll leave it right there. It's going to be that perfect square trinomial, right? If you notice that this last term right here, that C term, is a square, right? That's 2 squared, and this is obviously square. You could think, well, it might be x minus, and then that's really 2 squared, so that's going to be 2 squared, because this right here is the same as this a squared minus 2ab plus b squared. That's what this is. If you didn't recognize that, you could still just use the diamond method or some other method to factor it out, and just to see, all right, so I can factor out that x squared minus 4x plus x into that 12. Still have to deal with the 12, and then x minus 2 squared. So then that's going to be that first term right there. These two are equal, right? That's just more factored out right there. So our answers are first and fifth. Let's see how we did across the state of Texas. So this was tied for the 24th most difficult. We see just half of the students got full credit, both points here. Now, if you take your full credit and your partial credit, that's 86%. So that's decent, but this is, remember, just 1 point out of a 2 point, so this is still missing something. And if I were to guesstimate, they don't have information as to which of these answer selections were chosen most. I'm thinking most students could recognize this. I think the issue came with the perfect square trinomial. Probably I could see that messing some kids up, they knowing it's an x and a 2, but realizing that first off it's not a negative 12, and secondly that plus is not going to help us because we have that negative right there. So recognizing perfect square trinomials would be something that I think would be valuable for kids to work on, because sometimes STAAR questions are going to ask you just to recognize it, and we have to be able to recognize these perfect square trinomials. For number 25, we are looking at how to write quadratic equations. This is reporting category 4, TEKS 8.6b. Now, they're telling us it needs to be a quadratic function in vertex form. So in case we get stuck here, take a look. We've got vertex form right here. And I'm going to put it right there at the bottom of the screen. Take a look at that vertex form. That f of x equals a x minus h squared plus k. So we're going to need that. So let me expand this out here. All right, we're going to increase the transparency. So we need that vertex form. So if we just follow that form, we should be fine. Okay? So we've got this f of x, and we've got y instead of f of x. So let's just say y equals a x minus h squared plus k. Now, here's the one thing that they're not going to tell you, and you have to know coming into the STAAR test. What is the actual vertex? Okay, the vertex is 146, but the vertex in the vertex form, when they give it to you like that, the h is the x value, the k is the y value. Okay, so that's something that they're not going to show on the reference form, so you have to know that this h or this x is going to equal 1. So I'm going to rewrite this right as my vertex of x minus, and then my h is going to be that 1 squared plus my k is going to be that 46 right there. Okay, so I'm close. They actually give us a point it goes through. So you know what? I'm going to plug in these x and y values. I'm going to say my y is 10. I'm going to say my x is 3. So we're substituting. Okay, so I've substituted everything except for a. That's what I need, that coefficient. Let's solve for a. That's all we're doing here. Okay, so if we solve for a, let's just do this over here. So 10 equals a, that's going to be 3 minus 1, 2 squared plus 46. So 10 equals, that's going to be 4a plus 46. Let's subtract 46 from both sides. That's going to be negative 36 equals 4a. Divide by 4. So negative 9 equals a. Okay, so now I've got this negative 9. Remember, our vertex form is right here. So we can rewrite it here as y, I'm going to go back to the y and the x, equals my a is negative 9, x, and then I'm going to do this right here. I had everything here on the second row except I didn't know what the a was. Minus 1 squared plus 46. That's coming from the vertex right there. So we see that negative 9, x plus 1, there we go. My answer here is D. Let's see how we did across the state of Texas. This was tied for the 16th most difficult problem. Only 2 out of 5 students could get this correct, 40%. You see a pretty even distribution here. So this means that there wasn't one incorrect answer that really stood out. Most likely, if you didn't know it, you were just guessing here, latching on to a 46, right? Or maybe latching onto a 10, right? Thinking that, oh, that's the y-intercept, right? There's a lot there that could help us. But if we could just know that the vertex is HK, this is what's not provided, right? If we could at least get the vertex is HK. Look at that right there, that 1 in 46. Now, right, we can eliminate A and C because I've got the vertex. Now the question is my coefficient 9 or -9? We still have to calculate for that, but that would have been a much better if we recognize that the vertex is given to us in HK. So that's number 25. Let's see what number 26 looks like. For number 26, we are writing linear functions, TEKS 8.4c, in reporting category 2. Now, we get a table of data. It's a real-world situation, and they're not even asking us, like, what would be the number of customers after 8 hours or 10 hours. We could kind of eyeball that. But it looks like it's just a linear function based on my 4 answer choices. And when we see this and they're wanting it in the, in the slope-intercept form, hopefully we recognize at this point, let's open up our calculator. So first we're going to go to second 0 to open up that catalog. We are going to use linear regression because when in doubt you have a whole mess of data, you should be thinking, all right, I can use a regression model. But we need to make sure our diagnostic is on. So we are going to go down here to the D's, scroll down, and we're going to click on. Now what we need to do is we need to make sure that we hit enter and hit enter again for it to say done. All right. Now we go to stat. We hit enter. We are just going to enter in all of these data points. So the X is going to be our hours of sale after the sale began, right? That's going to be our L1. So that's pretty linear. 1, 2, 3, 4, 5, 6, 7. Now our L2, that's our f of x. That is going to decrease, but it's not going to be at a steady rate. If it were at a steady rate, it'd be pretty simple to calculate the m. But you know what? Let's let the calculator do the work for us. All right, so double check to make sure we've got all of our numbers correct. Everything looks good. So we just go to that stat. Let's see, let's hit that stat. Now we hit over to calc. It's number 4. It's that linear regression. Okay, because we're looking for something that looks like y equals mx plus b. Okay, and so they're going to give it to as that a and x, but that's fine. And so let's copy down what they've got here. All right, so they've got my a, so y equals mx plus b. They call it a, that's fine. That's going to be m equals negative 41. And then b equals that 337. Okay, so it looks like I could say y equals negative 41x plus 337. Now they actually, all they do is swap it. Okay, y equals 337 minus 41x. Okay, we could use the commutative property addition to add those in any order. So there we go. Our answer is going to be B. Let's see how we did across the state of Texas. So this was the 13th easiest problem, tied for 13th actually. Though 61%, a little bit more than 3 out of 5 students were able to get this correct across the state of Texas. A lot of these incorrect answers, they are going to come from students trying to hand calculate this, right? So the problem is it's not a steady rate. So if I were to take this as my x1, and this is my x2, and this is my y1, this is my y2, I could hand calculate a slope, but it would be different than if I did it with those two. And if I did it with, this range right here. So hand calculating is probably going to account for these incorrect answers here. So we need to focus on making sure students know how to use technology, when to recognize a regression model, and how to use the calculator to calculate it. So for number 27, we are looking at interpreting exponential functions, reporting category 5, TEKS A.9b. So we have this exponential function, and it is just asking us what one of the terms actually means. Here's the thing with exponential functions is we don't see anything on our reference materials. So if we're looking for reference materials, we're going to see factoring, properties of exponents, linear equations, quadratic equations, nothing about exponentials. So we need to bring that into the STAAR test with it. So here's our standard form for exponential functions, y equals a times b to the x. All right, so this is your initial amount, your starting amount. And then this b is going to either be your, let's see, it's going to be a rate, but it's going to be a growth rate if it's greater than 1. It's going to be a decay rate if it's less than 1. And then this x is usually some type of time frame, weeks, days, months, right? In this case, it's t years. All right, so let's put this w of t equals 270. Then I've got this 1.029 times t, okay? So 1.029 is in that b location right there, so that's going to be your rate. Your growth rate or decay rate is going to be a growth rate since it is slightly larger than 1. And so here we go. The answer is D. It's a growth factor of the number of whales in the Atlantic Ocean. So it's not a decay factor. See, it is a factor, but it's not a decay factor because it's not less than 1. So that's kind of tricky. But our answer here is D. Let's see how we did across the state of Texas. So this tended on the easiest, on the easier side here. This is the 18th easiest in the entire test. 57%, so almost 60% of the students got the correct answer here. You see our incorrect answers kind of skewed towards this one right here, the C. Almost 1 out of every 5 students thought that 1.029 represents the number of whales in the Atlantic Ocean at the end of the first year. Not sure why this would be the most chosen incorrect answer. That doesn't make much sense. This initial number of whales, that's your 270, right? This decay factor, like we said, that if it was less than 1, it would be a decay factor rather than a growth factor. Not sure where this one's coming from. So this one just says we need to go back and double check that our students are familiar with this y equals a times b to the x power, and then what each of these terms mean. So number 28 has us determining slope. This is TEKS 8.3a in reporting category 2. So we have a graph, but we don't really need the graph here. We just need to find the slope of this line here. Now, this is going to be confusing because you notice everything is a 2 or a 3, either in the numerator or denominator, positive or negative. So let's go to our reference material to double check. Look at our linear equations. Slope of a line, I'll put it right there at the bottom of the page. That's what we need. As long as students will follow that format right there, we should be good to go. Right? So m equals change in y, so that's y sub 2 minus y sub 1 over change in x, x sub 2 minus x sub 1. Doesn't matter which one is which. All right, so let's make this x1, y1, and we'll make that x2, y2. I'm also going to work it out the other way. So you see, it really doesn't matter. Okay, so y2 is going to be 2. My y1 is minus 2, so that's going to end up being a positive. My x2 is 4 minus, and then a minus 2, so that's going to end up being positive. Okay, so that's going to be 4 over 6, so 2/3. Now, what happens if we make this my x2 and make this my y2? Is that going to change anything? It shouldn't, because it shouldn't matter which order we do it in. So let's do that real quick. So my y2 is now negative 2 minus, and then my y1 is 2. My x2 is going to be 4. Let's see, no, negative 2 minus that 4. Okay, so now I've just got negative 4 over negative 6. So it ends up being the same thing, right? Two negatives make a positive, 2/3. So it doesn't really matter which way you do it. It's still going to end up being 2/3. So my answer here is going to be that C. Let's see how we did across the state of Texas. So this tended on the easier side. This was tied for the 17th easiest on the test, but not even 60%. Just 58% of the students got this one correct. Now, I actually plotted the points for us here, so hopefully we see it as an upward trajectory, which means it is a positive. It is a positive slope, so maybe that's why we didn't choose D as much. But if that's the case, I'm not sure why A was chosen more. So obviously, maybe we did all the work correctly and we just forgot to switch the signs, right? Because it's a negative 2/3 versus regular 2/3. But it is a positive slope, so I see why B is chosen. You just kind of eyeballed it rather than doing the calculation, right? Maybe you think it's run over rise rather than rise over run. And so this is pretty straightforward. We just need students to work on actually calculating the slope when given the points rather than just trying to eyeball it when plotting the 2 points. Number 29 has us looking at linear equations and the distributive property. This is a readiness standard, TEKS 8.5a, reporting category 3. So this is pretty straightforward. It's asking us, do we understand how the distributive property works? So distributive property is very important for us, right? So what this means is if you take an expression A, multiply it by, let's say, B plus C, right, within the parentheses, that means that you can distribute it out. So this is A times B plus A times C. So that's exactly what we're doing here. Okay, we're going to take that 5 and distribute it out. So we're going to take the 5, multiply by 2w, keep the plus, 5 times the 4. Right? The distributive property says this is the exact same as this. You just distributed it out. Now we're going to do the same thing here. Take that 4, multiply it by the 2w, keep that plus, 4 times the 9. Let's simplify. We've got 10w plus 20 equals 80 plus 36. Oh, that's a 2w, not a 20. Okay, so let's make it 8w. There we go. All right, so now we need the w's on one side. That's going to be, let's take away 8w from each side. That's going to be 2w plus 20 equals 36. Let's get rid of the 20. Right, that's going to be 2w equals 16 divided by 2. W equals 8. If we wanted to, we could plug in 8 into both sides and see that it's going to make a true statement. So our answer here is going to be B. Let's see how we did across the state of Texas. So this tended to the easier side. This is the 12th easiest. We see that 63% of our students got this correct. Now, why did some of our students get that 5 halves or that 28 over 9ths? That's just misapplication of the distributive property or basic computation errors. Here's what we should have done, right? If you think your answer is 8, let's plug that in. Because if it doesn't make a true statement, then it's not the right answer. Because 8 is going to make a true statement. But if you tried 5 halves, it's not going to make a true statement. If you tried 28 ninths, right, that's also not going to make a true statement. So this is going to be 5 times 16 plus 4, that's 20, equals 4 times, let's see, that is 16 plus 9, 25. Yeah, does 100 equal 100? That's correct, which means 8 works. But if you tried 5 halves, it's not going to work, not going to work, not going to work. Take the extra time, plug in your solution to the original equation, verify that it makes a true statement. So for number 30, we are looking at real-world systems of equations. This is TEKS 8.3g and reporting category 2. So we have this whole description here of 2 different types of tickets. Right, we've got standard tickets, we've got discounted tickets. The total amount of ticket sales from the standard and discounted tickets was this, $2,649. Now, the line graphed in the grid represents the first equation in a system of linear equations. Okay, so that's going to be big for us, is that it's a system of linear equations. So the second equation is y equals 0.80. Okay, what's the best estimate of the price of the discounted tickets? Well, we know that the discounted tickets are 80% of the standard ticket, but we don't know. So there's a few different options for solving this here. What I'm going to do is I'm just going to use the work they've already done for us. If they've already given us, right, this first line, we know that a system of equations means that the solution is where the two lines meet. Okay, so let's just plug in some numbers. If y equals, so I'm going to have x, then I'm going to have y. But remember, y equals, 8/10 of x. Okay, so I'm just going to plot a few different points here. So let's go 2, and that's going to be 1.6. And obviously, look at my scale of my discounted tickets. My y is going to be, it's counting by 5s. So that's going to be pretty low, to 1.6, right? Then I'm going to do 4. That's going to be 3.2. 6. It's going to be 4.8. All right, so my 6 is finally going to get me close to my 5. Okay, so I'm going to put that kind of right there. And my 4 is going to be my 3.2. What I'm doing is I'm trying to make a straight line here to connect these. So I'm going to jump down to, if that's going to be 6, I want to double that to 12. Right, that's going to be 9.6. I want to get close to these whole numbers up here on the y-axis. So 12 is going to be 9.6. So we're going to call that like right there, which means I'm going to do another 6. 18. Right, 18 times 0.8 is going to be at 14.4. Okay, so 18 is all the way over here, and then my 14.4 is not going to quite get there, but there we go. So we have at least crossed the line. So it looks like it's going to be right around there. Okay, that's an estimate, and we are simply looking for an estimate there. So this looks like it's the point, call it 14, 14.2 is my x value. My y value looks like maybe 10, maybe a little bit above 10. We'll call it 10.1. Okay, so let's look at my options down here. All right. So obviously this is just an estimate, but we see we're looking for the y value. The discounted ticket is that y value. And we're looking, and my line wasn't 100% straight. Maybe it needed to go a little bit higher. Not quite sure, but it's a little bit above that 10, and so the closest one to that, right, is going to be that 11.15. Okay, so because I wanted to plot the other ones, let me plot the other ones. 13.25, 14.55, 13.95. All of those other ones are going to be up here, like up here and up here. And there's just no way we get all the way up there. So our answer is going to be the closest one to our estimate of 10.1, and that is going to be 11.15. Our answer is D. Let's see how we did across the state of Texas. So this was the third hardest question on the test. Only 21% of the students got it correct. You see it's pretty wide distribution here. 34 is the most chosen, but it looks like we've got a whole lot of just random guessing, not really sure what's going on because we're getting close to that 25% each. This was actually the hardest test question that was multiple choice. The first and second hardest were new item types. So students had a 1 out of 4 chance of getting this correct, and they couldn't even get that. There was less than that. This is the first time this particular standard has been tested ever. Ever since we started the STAAR test in 2016, this has been one of these standards. It's never been tested, so I would guess that some teachers have kind of jumped over this standard because it had yet to be tested since 2016, but if it's a supporting standard, if it's in a reporting category, that means it is eligible to be tested, and it was tested. And it's difficult to make a graph of this right here, because you see the scale didn't really help us make a graph. And what we needed to do was just made a really good graph and then just guesstimate, since it is an estimate, right? And D is our correct answer because that was the closest that we got to about that 10.1. So for number 31, we are looking at recursive sequences. This is TEKS A.12c, reporting category 1. So we have a sequence, right? The first number of the sequence is 27, and then the f of the n, which the n would be the number in the sequence, is going to be 1/3 of the previous one. So let's see if we can just kind of plug this in here. So we know that the first term here they give to us is 27. And this 1 right here and these n's, right, these are going to be the number in the sequence. So first off, if your first number is 27, let's get rid of C and D because they don't have 27 as the first term. Okay? So f of 1 equals 27. Okay? So then f of 2, right, I want to take the second term of the sequence because I need the first 4, is going to be 1/3, and then f of n minus 1, so f of 2 minus 1, which equals 1/3 of f of 1, which we just said was 27. So really what we're doing is we're just going to take 1/3 of the previous number, okay? So that second number is going to be 1/3 of 27, that's 9. So f of 3 is going to equal 1/3 f of, remember that n is 3 minus 1, so that's 1/3 of f of 2, because 3 minus 1 makes 2. 2 is 9, so that's 1/3 of 9, so that equals 3. So I've got my first 3 terms, 27, 9, 3, and then we know we're going to do all of that. We're just going to end up taking 1/3 of the previous number. 1/3 of 3 makes 1. Okay? So that's how we read this, 1/3 of the previous number. That's all that means is the previous term. So my answer here is going to be A. Let's see how we did across the state of Texas. So this was the 18th, actually tied for the 18th most difficult. We couldn't even get 50% of our students to get it correct. Slightly more than 2 out of every 5 got this correct. Now, I understand why we're choosing B here. We knew that something was happening with 3, but instead of multiplying it by 1/3, they just ended up multiplying it by 3. That's all this is each term multiplied by 3. And then this was C. I guess I kind of understand that. We're just going to take everything needs to be thirds. And then D didn't really make much sense, so not many students chose that one. So this is difficult. It's actually a very simple concept of each term multiplied by 1/3. But how to translate all of this into that, there's a lot of n's and n minus 1. We need some extra practice interpreting that into a very simple rule, right? So if we can take it and just verbally describe previous term multiplied by 1/3, something like that. Verbally describing the rule, we can get students to understand and quickly move through the terms in the sequence. So for number 32, we are looking at the quadratic domain and range. This is TEKS A.6a, a readiness standard, reporting category 4. So we've got a quadratic function, and we need to find the range of G. All right, so if we take a look, if we wanted to plot this, right, we could. Look at our x values, look like they're going pretty much just one step at a time, right? So we got 1/2. If we wanted to just say 1/2 and then 1, that 3/2 is 1.5. Then I've got my 2, and then that's 2.5, and then 3. All right, so we're just kind of plotting along here, okay, from 1/2 all the way up to 3. So that's my 1, 1.5, 2, 2.5, 3. Okay, so what's happening with my g of x? These are my y values, right? So this would be my g of x. This can be my x. All right, so I've got my 7/4. So I'm going to need to turn these into mixed numbers, right? So that's going to be 1 3/4. That's 4. This is 4 and 3/4. All right, so if I can just, I'm going to make those that halves as well. That's 2. That's going to be 3 up there. All right, and then we're just kind of moving on. It kind of goes off the grid, but that's fine. So we'll make that a 3. We'll make that a 4, just to kind of keep it the same steps. And then it goes to 4, and then it goes back down to that 1 3/4, and then -2. So it looks like right at that 3/2, okay, that 1 1/2, it's going to get the highest right there. It's going to go to that 4 3/4. Right? It's because at the 1, it's at a 4. And then also at the 2, it's a 4. So it looks like it's just kind of downward facing, kind of hitting that vertex right there. That 4 3/4 or 19/4. Okay? So the range then is going to be all real numbers less than the vertex, and that vertex right there is going to be that 4 3/4, which is 19/4. So my answer is B. Let's see how we did across the state of Texas. So this was the 20th most difficult. You see, we only got 44% of the students that got this one correct. Honestly, I think the biggest challenge here was all of these improper fractions. Taking the time to write all of these as mixed numbers, because if they gave it to us just as whole numbers or mixed numbers, it'd be very easy to kind of see this peak, and then it goes back down here. But just taking the time to interpret all of these as mixed numbers or decimals if you really wanted to, that's the key, because once you do that, then it's pretty obvious if you want to graph it that this was the largest number. Everything else kind of went up to that and then came back down. So for number 33, we are multiplying polynomials. This is TEKS 8.10b in reporting category 1. Pretty straightforward. We've got 2 different binomials here, and we need to multiply them. Most of us will use FOIL. That is just an algorithm that we use based on our knowledge of the distributive property. So this is first, right, outer, inner, and then last. So we're going to take the first terms and multiply them, right? So that's going to be the 2a times the 3a, right? 2a times the 3a. And then we've got the outer, so that's the 2a and the minus 2. So I'll do it minus 2 and 2a. So we have to keep that minus in there. Inner is going to be that 5 and that 3a. And then the last, right, is going to be that 5 and the 2, minus 2 times 5. So we simplify. We get 6a squared minus 4a plus, we've got 15a, and then minus 10. Only thing to really simplify again would be that middle section there. So I've got 6a squared, 15 minus 4 is minus 11a, excuse me, plus a, plus 11a, and then minus 10. And so there we go. Our answer here is C. Let's see how we did across the state of Texas. So this was tied for the 14th easiest. I actually thought it'd be a little bit easier. Only 61% of the students were able to get this correct. Look at our number one incorrect answer here. Fully 24%, almost a fourth of the entire state chose this one. Well, look what happens if you just do the firsts, right? The 2a and the 3a. Well, that's going to be 6a squared. Then if you just do the lasts, 5 and then a negative 2, that's going to be a minus 10. So we've got the first and last, but we don't have the outer and the inner. So it looks like there's a good quarter of the students that still need practice with FOIL and how exactly to use that algorithm. So for number 34, we are writing linear equations, TEKS 8.2c. This is a readiness standard in reporting category 3. So we've got this verbal description, this word problem here, of this printer ink and You notice all of our answers here are just linear equations. We don't have any squared or anything, so there's no quadratics, no exponentials. So we need to find a linear function for the total cost for a single order of C cartridges. Okay. So we've got printer ink. Okay, that's $18.99 per cartridge. Okay, so that's per C. Per meaning multiply. So let's do $18.99 per cartridge. Sells the ink rate cartridges with a flat shipping fee, $7.95, no matter the number of cartridges. All right, so we're just going to add that. Since this isn't being multiplied by anything, that's what this means right here, no matter the number of cartridges purchased. That means you don't get free shipping if you get a certain amount. You're going to pay $7.95 no matter what. So we need to add that back in, $7.95, and then that's it. That's our T, right? So you see, we've got some C's. Look at that. We've got some C's and some T's flipped right here. Okay, so we need to make sure that the total cost T is on one side of the equation. So we've got that right there, and then the C is the per cartridge, right? All right, so our answer is D. Let's see how we did across the state of Texas. So this tended on the easier side. This was tied for the 29th most difficult. Remember, out of 50, 25 is going to be your halfway point. But just looking at the answer selections, you can easily see why almost a quarter of the students chose B rather than C. They simply flipped the variables. So sometimes we spend so much time focusing on how to interpret the coefficients and the variables and what's a constant, what's a coefficient. We don't focus much on double checking to make sure we have the right variables in the right spot. If you would have added these two together, that would have been 76%. That would have been one of the easiest ones in the whole test. But they gave us a decoy. 22% of us chose that answer. And so we need to focus on slowly double checking that we have our variables in the right spot. For number 35, we are looking at a readiness standard in reporting category 1, TEKS 8.11b. This is the laws of exponents here. So we have an expression. Seems pretty simple, just got x's and y's, but it's a drag and drop, right? And you could use each answer more than once if you want to. So it's a 2-point problem here. So let's see what we have, and we are going to just rewrite this a little bit bigger. All right, so x to the 6th, y to the 3rd, now divided by, right, x squared over y. Now, it looks a little bit weird to have a fraction within a fraction, so that's why they gave it to us, right, side by side. Now, there's multiple ways to do this. One way to do this would be to say, you know what, if you divide by 2, right, it's the same as multiplying by the reciprocal, right? Divide by 1/2, it's the same as multiplying by the reciprocal. So if I wanted to not look at it like this, I can just multiply this by the reciprocal, so that would be y over x squared. I just took this and flipped it. Okay, so that's going to equal x to the 6th, y to the 3rd times y over x to the 2nd. Now we need our reference materials here, and we've got the properties of powers working here. So when we get the product of powers right here, when they're both multiplied together, right, you just end up adding them. So it's going to be x to the 6th, and then we've got y3 plus, and that's a 1, okay, over x squared, and then the quotient of powers, right, that second one right there, you just end up subtracting them. So it ends up being x6 minus 2, because you subtract those two, y3 plus 1. It ends up being x to the 4th, y to the 4th. Now, that's one way to do it. Another thing we could have done is this negative exponent right there. Okay, see that negative exponent, a to the negative 1 is the same as 1 over. Okay, so what I could have done is, and we'll go ahead and put those 2 4s in there. Another option would be to just use that negative exponent. Okay, so x to the 6th, y to the 3rd, right, over, divided by x squared, and then that y, right, it's really 1 over y, right? So that's the same as y to the negative 1. Y to the negative 1. All right, now I'm going to use my quotient property to let me subtract these. So that's going to be 6x 6 minus 2, and then y 3 minus, and then I've got a negative 1, which ends up being same thing, x to the 4th, y to the 4th. So those are just 2 different ways to solve this problem. Let's see how we did across the state of Texas. So we finally found it. This is the hardest question on the entire test. Look, only 4%. I'm not missing a digit there. Only 4%, 4 out of every 100 Texas children got full credit, both points on this. What's scarier is not that we had 38% with partial credit getting 1 point. We had 58% of the students that got 0 credit. Like, we couldn't even figure out one of these two. So here's probably where the issue came with, was dividing by this fraction. Okay, most students know about the laws of exponents, but when you divide by a fraction, right, then they either need to work on multiplying by the reciprocal, right? So dividing by x squared over y is the same as multiplying by y over x squared, or taking, you know, the negative exponents, right? So x squared over y is the same as x squared times y to the negative 1. Okay, so these are more the fine-tune aspects of the laws of exponents. If we're just working on, you know, how do we do x squared times x to the 4th, that's easy stuff. Kids get that. They understand that you're just going to add those. But it's this, a little bit more complex, that or even power of a power or radicals, that's where we need to focus our work with students. So for number 36, we are writing exponential functions. TEKS 8.9c. This is a readiness standard in reporting category 5. So we've got this word problem here, this verbal description, and we just need to turn it into an exponential function. Now, remember, exponential functions follow this format right here, and it's not on your reference materials. All right, so this A is going to be your initial amount, your starting amount, principal, if you're investing. This B is going to be your rate. So it's either a growth rate. If it's greater than 1, it's going to be a decay rate. If it's less than 1, and then this x is usually some type of time factor. Okay, so let's see. If we know that, then this problem kind of writes itself. This year, the number of students who participated in sports was 317. Okay, so we don't have y. We're using f of x. Okay, and then so that's our initial amount, right? So that's just our raw number, 317. Each year, the number of students who participated in sports increases by 4%. Okay, so there's our growth rate. Now, here's the interesting thing. Since it's a growth rate, if we just turn that straight into a decimal, that's going to be 0.04, right? Which that would end up being a decay rate because that's less than 1. That's far less than 1. So when we're multiplying by a growth rate, right, we have to take the percentage, that's the rate, and then we have to add 1 in there to maintain the principal. So it ends up being 4% over 1, because multiplying by 1 is just nothing. So we end up having to multiply that rate over 1 in order to keep that principal going. And then x years, boom. So there we go. So 317. And then we've got the 1.04. Looks like our answer is C. Let's see how we did across the state of Texas. So this was the 24th most difficult, so right in the middle of the test in regards to difficulty. Only half the students could get it correct, and this does not surprise me. It's that 4% right there, not knowing that that 4% translates into 0.04, but then in order to maintain the principal, you have to add 1 to make it 1.04. Yeah, that takes a few extra steps, and just grabbing that 4 and putting that 4 right there would make sense if you didn't know how to interpret it correctly. So that's the issue there, is how do we multiply by a growth factor or decay factor, and what does that look like? That's where the work needs to be done on this particular type of problem. So for number 37, we are writing systems of equations. This is TEKS 8.2i, a readiness standard in reporting category 3. So we have two different tables here, and they both represent one equation in a system of equations. We need to write the equations, and we notice that they're going to be in standard form. Right? So we're going to be using these linear equations. All of our answers are going to be written in standard form. That's that top one right there. But we are going to start by writing them in slope-intercept form by using the slope of the line. So we need all three of those equations: standard form, slope-intercept form, slope of a line. All right, so let's give ourselves a little bit of room, and let's do that. So let's find the slope here of line A. So my slope, it's going to be y sub 2 over y sub 1, and that's x2 over x sub 1. So rise over run. So let's pick the smallest numbers right here. Let's make that x1 and x2, y1 and y2. Okay, so that's going to end up being -9 minus 21, and that's going to be 4 minus -1. Okay, so that's going to be -30, and that's going to end up adding over 5. So it looks like my slope is -6. All right. Now, I'm going to use my slope-intercept form, y equals mx plus b, but I'm just going to end up substituting a pair of that I did not use. So my y is going to be 51. My m is -6. My x is going to be also -6 plus b. Now I can solve for b. So that's going to be 51 equals 36 plus b. So if I take away 36 from both sides, right, that's going to be b equals 15. All right, so if I wanted to write this particular line A right here, I could say y equals -6 plus b, but if I want to do that in my standard form, I need my x and y on the same side. Let me just add x, 6x to both sides. That's going to be 6x plus y, and that b I already know is 15, equals 15. So 6x plus y equals 15. All right, I see that on D. So let's double check and make sure we get the correct answer on line B. Same thing. So my slope is going to be y sub 2 minus y sub 1, x sub 2 minus x sub 1. I'm going to pick the smallest numbers I can, just to make it easy on myself. y2, y1. All right, so that's going to end up being 3 minus -12 over, and you know what? Let's make that, we need to match up the x2s and the x1s. I'm going to make it -4 minus 1. So that's going to be 15 over -5, -3. So y equals mx plus b. Let's substitute in that right there. So 18 equals -3. My x is -9 plus b. We're going to solve for b. 18 equals 27 plus b. We're going to subtract that. We're going to get b equals -9. All right, so if I want to rewrite this, I can say y equals, my m is -3, -3x minus 9. Once again, I need my standard form. So let's add the x over here to get that. So 3x plus y equals -9. Let's see if that's our second one down there. And there we go. So that is our answer D. Let's see how we did across the state of Texas. So this was the 15th most difficult. And honestly, not even 40% of our students could get this correct. Look at our 3 incorrect answer choices. Pretty even distributed. The only thing is we had a few people more do D, a few people less do A. I have a feeling there was a whole lot of guessing going on. Not because there was complicated calculations. It was just a lot. You saw how long it took me to solve just for line A. Then I had to do all that for line B. So students need work on using multiple equations, whether it's the slope of a line, the slope-intercept form, and then translating it to standard form, and then just stamina. Sticking with the problem, even though it does take quite a lot of calculations. Sticking with it until you get it right. So for number 38, we are looking at parent functions. This is TEKS 8.7c, reporting category 4. This is a readiness standard. Now, parent functions just change a graph. So we've got a basic function right here, right? So you've got your standard vanilla quadratic right here. So if we wanted to draw that, we would say we've got this f of x equals x squared, right? It's going to go right through the origin right there as my vertex. Okay, because there's nothing that changes that. That's just the most standard form you can get here. Now, what do we do with this x minus 3 and the minus 1, minus 9? Well, first off, if you have something that shifts it within the parentheses, right? So this is going to be x minus this minus 3. This minus 3 is going to shift it left to right, but it's a little bit counterintuitive. If it's a minus 3, right, this 3 is going to shift it to the right because we're looking at x minus and then whatever that term is, that a. Since that a is a 3, right, then we're going to actually shift it over 1, 2, 3 over to the right. So it looks like it's a minus 3, but it's actually shifting to the right. So the x value is going to be 3. Then, when we get outside, that negative 9 actually does shift it down. So outside of the parentheses shifts it up or down. So now we're going to go down to right about here. So it's going to look something like this. It's going to be 3, negative 9. Now, if you're not 100% sure, let's graph this. Okay? So I'm going to graph my, first my basic, right? So y equals x squared. Okay, so there we go. Now, I'm going to do this other one. I'm going to say y equals, I need my parentheses. Now this is f of x. Remember, it's going to end up being squared, right? So I need the parentheses. I need x minus 3. You need to close it. I do need to square it because it is a quadratic. See how that shifted it over 3? That green shifted over 3. Now my minus 9 is going to shift that down, and there's my vertex. So if you know how to build it in the calculator, you can also visually show it down there. So that's my answer, 3, negative 9. Let's see how we did across the state of Texas. So this was the 5th most difficult problem, tied for 5th actually. Only 30% of the students were able to get full credit. And that's because usually when we do graph transformations, we do one or the other, right? So we might do this, g of x, equals f of x minus 3. Or we might say g of x equals f of x, and then that minus 9. But what this one did is it combined it into 1. So this lets me know that when we practice this with students, we need to have multiple transformations within the same problem so they can see how the vertex moves both horizontally and vertically. So number 39 has us looking at rewriting polynomials. This is TEKS 8.10d, reporting category 1. We simply have an expression here that we need to rewrite it using the distributive property. Hopefully we notice that we've got some common factors. Okay, so I'm looking at 24 g h. I'm going to separate all these three so we can see what the common factors are. I've got a negative 12 g squared, and I've got an 18 g. All right, so there's nothing I can do with the h because it's the only one that's there, but take a look at this column right here. Okay, I've got g squared, g. So out of all three of those, I can pull out a g. And then 24, 12, negative 12, 18, right? I can pull out the biggest one I can pull out is a 6. So I can pull out a 6, okay? So what happens then if I pull out a 6g? Okay, so what I need to do is divide each of these three terms by 6g. So 24gh divided by 6g, right? That's going to be 4, and the two g's cancel. So it's just going to be 4h. Now I've got my negative 12g squared. Divide that by 6g. Okay, so that's going to be negative 2. And then g squared over g just becomes g. So minus 2g. Then I've got my 18g. 18g over 6g. The g's cancel out, and that just becomes a 3. So just a plain old 3. All right, there we go. So we have factored it out. Our answer there is going to be C. Let's see how we did across the state of Texas. So this was the 20th easiest, tied for 20th easiest actually. So it's not really easy, but it's easier than it is harder. It's more on the easy side of the test. 55% of us chose the correct answer, and it didn't look like we had some random guessing. It looked like a good quarter of us chose this B. So let's take a look at that real quick. So I see what they're doing on B. They just, unfortunately, they just skip looking at that 18G, right? Because look what happens here. Is if we have the 12G times the 2H, right? You're going to get your 24GH squared. And then 12G minus 12G, right? That's obviously not going to work. The G squareds work, but that'd be 144. So really, I think they're just looking at the very first item and making sure that that works. But the problem is all four of these answer selections have the first item that works. So the easiest thing to do is once you take your answer, right, distribute it back out. 6G times 4H. We didn't do that, but we easily could. Minus 2G, and let's multiply that by 6G, plus 3, 6G, right? It should equal 24GH, right, minus 12G squared plus 18G. It should equal what you started if you distribute it back out. This obviously wouldn't, and neither would any of these other ones, so C is our answer. For number 40, we are looking at solving systems of equations. This is standard 8.5C. It is a readiness standard, reporting category 3. So we've got this real-world situation here about a company advertising at different sites, and they get number of clicks on site 1, site 2, and we're asked what is the price or the cost of clicks on website 1. Okay, so let's do this. Let's make that X, let's make that Y. Okay, now if we've got these 2 days, Monday and Tuesday, this is setting up to be a system of equations because we've got this system 1, right here is Monday, and then we've got the system 2 as this Tuesday. So let's see if we can just write this, okay? So we'll write 15x plus 29y equals 94.15, okay? Now, we've got 25x, okay, plus 29y equals 121.15. Now, I want to know what website 1 is. That's my x. But we know with systems of equations, they share an x or y. You can, subtract the two equations from each other. Take a look at this. If I were to subtract all of this, right, which is the same as multiplying them all by -1 and adding, it's the same thing, right? So let's subtract. So if I do that, I'm going to subtract, which means that's going to be a negative 25 and a negative 29, right? That's going to end up being negative 10x. My y's go away, which is exactly what I need, right? And then this is going to be negative 27, okay? Divide both sides by negative 10. Gets that negative out of there. and that's going to be 2.7. So x equals 2.7, and if we want to make that real world, it's going to be $2.70. So our answer here is D. Let's see how we did across the state of Texas. So this was the 8th most difficult problem on the test. We couldn't even get 1 out of every 3 kids choosing the correct answer. And if you take a look at our answer pattern, our distribution here, this looks an awful lot like guessing. And so we've got a lot of kids guessing, and then a few kids worked it out. That's why this one's a little bit higher, and this one's a little bit lower. That's 16%, but other than that, we're just kind of all over the place here. So what's the difficult thing here is adding or creating these systems of equations so that you can add them. From a real-world situation, look, they give it to you in a table, so that's a lot easier than sometimes all you're going to get is this verbal description here. But this is where students need to spend some extra time with real-world situations, identifying it as a system of equations, and then writing the systems of equations. Because we didn't even have to do anything. Sometimes you have to multiply one of the equations by a certain number in order to make the variable coefficients line up. But they gave you 229s, right? And you just had to subtract the 2 equations from each other, and it eliminated the variable that you didn't want. So it was kind of set up for us, but we first need to recognize that it is a system of equations and turn these tables here into actual equations we can subtract. Number 41, we are solving quadratic equations. This is a readiness standard in reporting category 4, TEKS 8.8a. So we've got function k, and we've got this quadratic here. So let me copy this over, because hopefully you're noticing we've got this, right, this x squared plus 32x plus 248. Look at all our answer selections. They all involve radicals there, which means probably going to need our quadratic equations. So let's do that. Let's bring that quadratic formula out here. And I'll put it right there at the bottom of the screen. All right. So we need to identify the A and the B and the C. Okay, so remember that this is ax squared plus bx plus c. Okay, so my a is going to be right there, so a just equals 1, there's nothing there. B is 32. And my c equals 248. All right, so let's plug in the quadratic formula. So x equals, and then negative b. All right, so that's going to be negative 32 plus or minus square root of 32 squared minus 4 times a is 1 times 248. That's my c over 2a, 2 times 1. All right, I've got that. Now I definitely need my calculator. So let's open that up here. All right, we got first 32 squared. Okay, that's going to be 1024. So x equals negative 32 plus or minus square root of 1024 minus, and then 4 times 1, that's just 4. 4 times 248. 4 times 248. 992. And then over 2. Okay, so let's multiply that by negative 1 to make it negative 992, and then let's just add the 1024. Of course, we need to not put a decimal in there. There we go, 32. All right, all that work for x equals negative 32 plus or minus square root of 32 over 2. Now, the question is, can I simplify this right here? Square root of 32 And yes, you can, because I can see a perfect square in there. I can see that as square root of 16 times square root of 2, right? These two make the square root of 32, and watch, I can simplify square root of 16 into 4, right? So that's using our knowledge of how to simplify, right? Square roots, and so I'm going to rewrite this as x equals negative 32 plus or minus 4 square root of 2. Now, I've got two different terms here. I've got a term here and I've got a term here. Watch. I can actually simplify that. Negative 32 over 2 is going to be negative 16 plus or minus, and then I can't do anything of that square root, but 4 over 2 just makes 2, plus or minus 2 square root of 2. So here's my answer. If I want to write it this way, negative 16 plus 2 square root of 2 and negative 16 minus, right? We say plus or minus, but that's really what it means is you kind of split it out like that. And we've got our answer here as very close to A and B, but notice the negative 16. It's been negative the whole time. So my answer here is A. Let's see how we did across the state of Texas. So it shouldn't surprise you that this is tied for the 5th most difficult, because that was a lot of work we did here. And first we needed to apply the quadratic formula, but then I think what really might have messed us up is simplifying, right, that square root of 32, right, into this square root of 16 and the square root of 2. Because once you did that, that's when you could, remember we had this, I think it was this step right here, of realizing that that is, okay, I can distribute that out, I can do this, 4 square root of 2, because this is really what we ended up doing. And then we just simplified all that, right? Negative 16 plus or minus 2 square root of 2. I think it was that last step that really probably messed some people up, because take a look. Look at A and B. You would think that this would be a very highly selected incorrect answer, because look how close it is. It's just missing the negative, but you know, it's not. It's no different than this one right here, which looks very close. Look at these right here. All they did was they just dropped off the 2. They're like, oh, let's just make the 2 denominator go away. But even then, that wasn't any higher, which means it makes me think that we're getting a lot of guessing here, because these two, I kind of see where they're coming from. So a lot of guessing. We need some extra work on applying the quadratic, especially when the answer is not neat and clean. A lot of times you'll get an answer and it ends up being plus or minus like square root of 25. It's like, okay, that's easy. But what happens if it's plus or minus the square root of 90? Something that doesn't have a perfect square root. Can you factor something out of it? Because when you have to factor something out of it, that just increases the complexity. Number 42, we are graphing exponential functions. This also is a readiness standard. It's in reporting category 5, TEKS 8.9D. So we have a customer purchasing an electronic device for $650. And the value is going to decrease, all right? So it doesn't tell us exponential function, but we have a few keywords here. We have an initial starting price. We always need an initial number, and then it's going to decrease, but then right here, the x years. Okay, so when your x value happens to be a time, that's going to make you think, all right, we should be thinking exponential function right here, because our a is going to be our initial value. This is going to be our rate. It's going to be either a growth rate if it's greater than 1. It's going to be a decay rate if it is less than 1. And then this is usually your time right here. You're exponentially growing it or decaying it. And so this, to me, seems like it's an exponential function. So let's see if we can plug some of these in here. Okay, so y equals, what's my initial amount? $650. What's my rate? It decreases by 30%. Now here's the thing. 30%, that's going to equal 0.3. But the full value is 100%, right? So here's the thing. If we want to have a decreasing rate, we have to take this away from the full value. So really, every year, it's only 7/10 of its remaining value. So we're going to multiply it by 0.7. It is a decay rate because it's less than 1, but we're not going to multiply it by 0.3. We're going to multiply it by how far off it is off the full 100%, or 1. And then x. Okay, now if I set all that up, now look what I have. The y-intercept, the graph is a vertical asymptote. Okay, so we're going to need to graph this now. So let's graph. You know what, let's do this one. Desmos here. Alright, so let's say y equals 650. We're going to multiply that by 0.7, raise it to the x. Okay. Now let's see what we've got here. Let's zoom out a little bit. Okay. So it looks like it's got that, that horizontal asymptote at y equals 0. It's asking me about the y-intercept. Wow, y-intercept is, okay, 650, right? Because that's the initial value. That makes sense. All right, so let's see what we've got here. So the y-intercept of the graph is at 650. Okay, that makes sense. That's that initial value, right? When x is 0, right? When x is 0, y equals 650, so that makes sense. So we can't have a y-intercept at two different spots. It did not have a vertical asymptote. The asymptote was horizontal, right? It was continuing to kind of grow out like this, and it was at this y equals 0, not y equals 30. That's not going to make any sense. It was at y equals 0 and doesn't have vertical asymptote. All right, so our answer here is A. Let's see how we did across the state of Texas. So this was on the easier side. It was actually tied for 20th easiest on the test. 55% of our students got it correct. I think some of the issue here is simply translating this into something that you could use, right? Translating the word problem here into this exponential form, especially since the exponential form is not on the reference materials. Once we do that, most students are comfortable plugging it in. Then we do get a little bit of vocabulary, y-intercept and the asymptote, but if we look at these answer selections here, there's not one word that tripped us up because this does look like it's pretty evenly spread here. So I think the issue here really lies with turning this verbal description, this word problem, into an actual usable form that you can graph. Number 43 has us graphing inequalities. This is TEKS 8.3D, a readiness standard in reporting category 2. Now there's a lot going on here. We need to graph this, and we need to decide what type of line it's going to be, and if the solution set is going to be below or above the line. So let's first see how are we going to graph this linear inequality, okay? So really the problem here is how to answer the question, because this linear inequality is fairly simple, right? So if they give it to us like this, then that's going to be our slope-intercept form, right? So this is our slope. So what do we know here? Y equals mx plus b. So I don't have a number there as a coefficient, so my slope is going to equal -1, because you could always infer a 1 there. And then my b, right, that's my y-intercept. That's just going to be 2. All right? So we know one point is going to be right here. That's going to be my y-intercept. And I can plot a second point because it says I need to select 2 points. So I'm just going to start with that one, and then I'm going to use the slope to find my second one. That's going to be rise over run, right? So negative 1 over 1 is the same as negative 1. So I'm going to go down 1 and then over 1. So I'm just going to go right there. So those are going to be my 2 points. Now, it is going to be a solid line because it's not really, an equal sign. It's greater than or equal to. So that means that we're going to have this solid line that kind of runs all the way through there. I'm not doing it perfectly, but that's fine. And then we've got to figure out the shading. Okay, where does the shading go? Well, if it's going to be greater than, it's going to be above the line. Okay, we can test this by, let's just choose a point. That's easy. Let's choose 0, 0. Okay. If I substitute 0, 0, it should be false because I shaded on the other side. So my y equals 0. So y is greater than, or 0 is greater than or equal to 2. See, that's false. So that's how it looks. Now, the tricky part is I've got to actually make it happen here. So I've got my first point there, got my second point right there. It automatically draws the line for me. It is going to be solid, right? So I'm going to go ahead and keep it as solid. And then my solution set, I just need to choose a selection. And you see I can kind of go either way. And in order to deselect it, you have to kind of click it twice and then move it to the other side. So I'm going to keep it up like that. That looks exactly like I drew it, and so that is our answer. Let's see how we did across the state of Texas. So this was tied for the 5th most difficult. We see only 30% got full credit here. This is a 2-point problem, and only 12 got partial credit, getting 1 point, which means more than half of our students got 0 points here. There is a little bit of trick here trying to find the 2 points from here. Hopefully we recognize 2 as our y-intercept, but then we have to use the slope to find that second point. But really the difficulty is the actual answer type itself. This graphing is not as intuitive as you would like, and so as much as possible, if we can, maybe not necessarily on an electronic format, but have students just take an inequality, graph it with 2 points, and then shade it and justify it. If that becomes secondhand nature, then transferring that skill onto this test format will be a little bit easier and would ensure at least partial credit in the future. So, number 44, we are writing equations for parallel lines. This is TEKS 8.2e in reporting category 3. Now, we've got one line that's drawn for us here, and we need to find an equation that represents the slope-intercept form of the line that passes through point P, but here's the key right here. Passes through point P and is parallel to line M. Okay? So, there's no information on the reference materials that tells us why parallel lines are so special. But parallel lines, this is the one piece of information. If we don't know this, then we're just going to have to guess. Have identical slopes. So if we can remember that parallel lines have identical slopes, all right, then we're going to want something that's kind of like, kind of like this, right? Parallel, never getting closer, never getting farther. So I've got this M right here. So I need to write it in my slope-intercept form, right? So we see that down there. So that means I need those two pieces. I need my slope, and I need my y-intercept. So let's figure out the slope first. Since parallel lines have identical slopes, let's find the slope of this right here. Okay? So you've got this point right here, 2, 0. You've got this point right here, 0, negative 3. Okay, so remember our slope is change in y over change in x. Let's label these here as x1 and y1, and then x2 and y2 to find the slope of this line right here. So that's going to be y2 is negative 3 minus 0 over 0 minus 2. So it looks like it's going to be negative 3 over negative 2 So really it's just going to be 3/2. The two negatives cancel out. And that does make sense. If it's moving up from left to right, it is a positive slope. And some of you just kind of eyeballed it, right? You just kind of started from here, and you're like, all right, 1, 2, 3 down. And then 1, 2, 3 to the left. So that's -3 over -2. Either way, that works. So I've got, this needs to be y equals 3/2 x. Now I need the y-intercept, and I don't think my drawing is good enough. So eyeballing it is not a good idea. But you know what? We've got point P here. -2, 2. Let's plug that in. So if my y is 2 equals, because I'm going to use my y equals mx plus b, I know my y and my x from this point right here. And I know my m, I just figured that out, that's 3/2. So 3/2 times my x of -2 plus b. Simple. Let's simplify and solve for b. Alright, so those two are going to cancel out. That's just going to be -1. So it's going to be 2 equals -3, because 3 times -1 plus b. Let's add 3 to both sides. And that's b equals 5. That was close. That was 5-ish on my line right there. So here we go. Y equals 3/2 x plus 5. That would be a line that passes through point P. It's parallel to line M. And there we go. My answer is C. And let's see how we did across the state of Texas. So this was the 17th easiest. So it's not super easy, but it's more on the easy side than the hard side of the test. Almost 60% of our students got this correct. Now let's take a look at these two answer selections here, because we know that the test graders don't just put random answers up here. So this A, you notice, has the correct slope right there. It's right. It's got the identical slope. What they did is they inverted this y equals mx plus b. Once you substituted that, this point right here, right, the -2, 2, this is what happens if you say the y is -2 and the x is 2. If you substitute that in with the correct slope, you're going to end up getting that right there. So they did all the work of finding the slope and then substituted it in correctly. Which, when you're reading from left to right, the x is first, but when you're reading this from left to right, the y is first, so I get that. And then this right here, remember, parallel slopes are parallel lines have identical slopes. This is a perpendicular slope, because perpendicular slopes are reciprocal. Okay, so they just flipped it to the 2/3 and then plugged it in, and then they got that. So that's where our A and our B got from this perpendicular rather than parallel. We knew one was identical, one was reciprocal, but our answer here is C. For number 45, we are working on the properties of equality. This is TEKS 8.12e, reporting category 1. So we have this basic equation here, the S equals pH plus 2b. All we need to do is solve it for b. So we're going to just kind of call out some of the things we do intuitively. If we want to solve for b, right, we need to think, well, how can we isolate that b? Right? We're thinking of our PEMDAS, but we're actually going in reverse order when we are trying to isolate a variable. Okay, so we're going to start with this addition. See this addition right here? Okay, that's the easiest thing to get rid of because we're going from the bottom up. So I've got a positive pH, right, and a positive 2b. I've got two different terms right there in that binomial. And so let's just subtract pH from the right side. And this is the subtraction property of equality, saying if you subtract from one side, you need to subtract from the other side. So we're going to subtract this. S minus pH equals s minus pH. You can't do anything with that. Those terms are not alike. But I've got this pH plus 2b minus pH. I line it up here vertically just so we can see that it cancels out, but pH minus pH, right, cancels out, so now I've got this 2b. Then next I've got this multiplication. It's 2 times b. So after I took care of this, now I can take care of my multiplication. And if it's being multiplied, right, we're going to use the division property of equality, because we're going to divide this side by 2. But you can't just divide one side by 2, you have to divide both sides by 2. And 2 over 2 just equals 1. So really it's b equals s minus pH over 2. Our answer here is A. So let's see how we did across the state of Texas. So this was actually the 22nd most difficult. It landed more on the difficult side than the easy side. I'm not going to lie, that's a little surprising for me. Not even half of the students could correctly identify this. So this lets me know that the properties of equality, which we use basically in every single problem in Algebra 1, when called out on their own, sometimes can confuse students, because typically we're isolating for a number. We want to know what does x equal or what does y equal. But right now we're just trying to find what b equals, and all the other letters can't be simplified in any way. So students need extra practice on just the properties of equality themselves, rather than using the properties of equality to always be solving for a variable. Like this right here, the second most chosen answer selection, right? This b equals s pH. Well, you see what they did here. All they did is they multiplied both sides by pH, because they thought that was going to get rid of the pH, right? So they thought that multiplying both sides by the pH rather than dividing, obviously, that's going to get you the s pH equals 2b, and then they divided by 2, right? But obviously multiplying both sides by pH, it's not going to get you it. But a full quarter of the students thought that was it. So practicing properties of equality and not simply solving for an actual variable, but just solving for one of the random variables in there, helps students practice how to use them. So for number 46, we are looking at the domain and range of linear functions. This is TEKS 8.2a, Readiness Standard in Reporting, Category 3. So all we have here are x is greater than 5, y is less than 2. Which graph could best represent this? And we've got all of these rays pointing in all kinds of different directions. And I can see how this could be difficult because, number one, we're getting towards the very end of the test, and keeping the x and the y's separate can be a little bit challenging. So this is what I'm going to do. I'm going to go through all 4 answer choices here, and I'm just going to look at the x's first. I'm not going to look at my domain. So x is greater than 5. So let me put that right there. So I need x is greater than 5, and then y is less than 2. All right, so x is greater than 5. And then we'll do blue, y is less than 2. All right, because if I try to do the x and y in each one, I might end up getting mixed up. First off, we notice that we have open dots on all of these. These open dots represent less than or greater than, no, greater than or equal to, less than or equal to. So we can't eliminate any answer choice there. So I'm looking at my domain right here. So that's my x, right? My left and right. So this right here, I've got it at a 5, but it goes to the left. So this is x is less than 5. So that's a no. I've got my c here. I've got, once again, x is less than 5. So that's a no because it goes to the left. This one has, it's down, but it is going to the right. X is greater than 5, right? Because my left and right, it goes to the right, and then same with this one. Okay, so I've already eliminated 2 answer choices, A and C, and so let's check them all again. So I need y is less than 2, so it needs to go down. And see, this one has got y is greater than 2 because it's going up, So that's a double x. This is y is less than 2, so the range is correct. The domain is incorrect. Now let's check B or D. So I've got a y as less than 2, so it's going down, so that's looking like that's going to be it. Because this is going up here, y is greater than 2. That's what makes that incorrect. So there we go. Our answer is B. Let's see how we did across the state of Texas. So this is the 11th most difficult. You see, barely over a third of the students got the correct answer there. And take a look at the distribution here. 23%, 24%. That's a little bit lower than 25 because this is a little bit higher than 25. But all of this makes me think that we are just guessing. You see that we had to do quite a bit of analysis, and I had to do it on each of the 4 graphs. And that just goes to stamina, because that takes quite a bit of work. And sometimes, rather than applying those 2 different colors that I did, evaluating just the domains first, just the ranges second, we're just going to try to eyeball it and just try to look at it, and that's where mistakes get made. So this type of problem definitely needs to be practiced with students, and where they're evaluating multiple graphs at the same time for certain conditions for the domain and the range. Number 47 has us evaluating functions. This is TEKS 8.12b, reporting category 1. Pretty straightforward here. We've got a function, g of x, and we want to know what g of 20 is. Now that particular notation might confuse us a little bit if we're not used to it, but look at g of x. Look what we're substituting in. That's where that x was. So if g of x equals this right here, so this is what g of 20 is going to be. We're going to substitute in that 20 for the x. That's it. Once we recognize that, I'm going to put in that 20 for the x. This is simple order of operations. So g of 20 equals 6 times 2 times 20 is 40 plus 7, right? And then so g of 20 is going to equal 6 times 47. We can either use a calculator or just do it the old-fashioned way. That's going to be 2428. So 282 is our answer, B. Let's see how we did across the state of Texas. So this was tied for the 11th easiest. Pretty straightforward as long as you recognize what to do here. Some of these incorrect answers come from an improper use of the order of operations, right? So we've got this right here, 2 times 20, right? Some of these answers can be what happens if you add the 20 and the 7. So you do the 2 times 27, right? You don't add those first, you multiply first, but if you were, you can get one of these answers. And then sometimes we would, you could just do the 6 times the 2 and 20 and 7, but then you could end up just, adding the 7 to the 2, right, to get 9 times 20. I mean, there's all different ways to kind of do this incorrectly. That's where some of these incorrect answer choices from. So ultimately, we just need to work on solidifying our use of the order of operations and making sure students are used to identifying this g of 20, that's the x, because that might have thrown a few students off. Number 48 has us graphing functions and identifying the features of those graphs. This is a readiness standard in reporting category 2, TEKS A.3c. So we've got a graph right here, and look, they're just asking us for the y-intercept and the x-intercept. Pretty simple. They're not even disguising the term x-intercept as a 0 or a solution, right? So my y-intercept is going to be, and it looks like we are using the full coordinate pair, right? So that's going to be always an x of 0. That's how we know it's y-intercept. Looks like it's the y value of 8. And I'll put that up there. My x-intercept is going to be an x of -2, and the y value is always 0 on the x-intercept. And so let's see. It looks like we've got our answer there as C. And let's see how we did across the state of Texas. Well, it took us 48 problems, but we finally found the easiest problem on the test. Almost 4 out of every 5 students got this correct. You notice what we did here on A. This is the most chosen incorrect answer, and they just flip-flopped, right? They just flip-flopped the values here, but at least the values are correct. These other ones didn't even have the correct values on there. So good job, State of Texas. Almost 4 out of 5 students got that correct, and that was pretty easy. We're just recognizing the x and the y-intercepts and how to plot them. We've been doing that since the 5th grade. Number 49 has us looking at attributes of quadratic function graphs. This is a readiness standard, TEKS 8.7a, in reporting category 4. And we're just trying to find the zeros of the function. This is a multi-select, right? So if I just try to select 1, it is going to give me this error message that says you haven't selected enough. And if I select the first 2, I cannot select a third. It's impossible to select more than 2. So zeros. If you know what this word means, then it's going to take 2 seconds. If not, you might need to do a little bit of work. Okay, so 0. This is what we're thinking of. Zeros are also called solutions, right? Because this is what we're thinking of. If f of x equals 0, that's where the term 0 comes from. What is that x value? F of what? What is the x value that makes the y equal 0? Which means if the y equals 0, right, and that means this is going to be our x-intercept. So it's a little bit easier to recognize when it's called an x-intercept, but it's also called a 0. It's also called a solution. Don't know why it needs three names. Look at that right there. I've got 2 zeros right there. I'm just looking to see where the graph crosses the x-axis, but we need to know that the 0 is the x-intercept, is a solution. So I've got one at 3, and I've got one at -1. So there we go. I've got 6 possible choices, right? But I'm going to choose those 2 right there. -1 and 3. Let's see how we did across the state of Texas. So this did fall on the easier side. This was the 12th easiest. Full credit got almost 70%. If you would put that together with the partial credit, that's 90%. Got at least 1 point on this. So there was 10% that had no credit, and I really think that issue does come from not understanding what that word zeros means. Now, if we can recognize that zeros are solutions, are the x-intercepts, then things like this become easy. It's just a matter of drilling that vocabulary into students in multiple forms. We finally made it to the end. This is the last question on the test. Number 50, rate of change. This is a readiness standard in reporting category 2, TEKS 8.3b. So we've got this table here of construction worker building up steps. It's a linear relationship, so that's helpful. So it's going to be a constant rate of change, constant slope. We're looking for that rate of change with regard of the height off the ground with respect to or number of steps, right? And typically we'll put the x over here and we'll put the y there. So if the height is the y and the number of steps is the x, y per x, y over x, the rate of change, guys, they're asking us for slope. That's what that is, change in y over change in x. So let's see, looks like we've got, looks like it's pretty constant. Look at that, that's 2, 2, 2, 2. And then it's going to be 14, 14, 14, 14. Now remember, it's the change in y over the change in x. So the change in y changes 14 for every 2. We need to identify that it's the y over the x, not the other way around. That's going to be an incorrect answer choice. So our answer is going to be C, but you notice we do have that 1/7 if we flipped it. Let's see how we did across the state of Texas. So this was tied for the 7th easiest, right? 7 out of 10 kids were able to get that 7 inches per step. Actually, this 1/7 was the second most chosen incorrect answer. It was this 14. So we were just looking at the 14, which all of these are 14. But we need to realize that the x was changing by 2, so you had to cut that 14 in half. That's the tricky part there. Other than that, we did a pretty good job on this.